We'll start the we'll start today class. Just we will overlap little bit yesterday class. What is mean by MRT? Now, if you take we started our evaluation from the bottom plate. Bottom, what is the minimum thickness allowed is? I told 0.09 inch. 0.09 inch is 2.3 millimeter. If any 100 square inch area, if average thickness is less than 0.09 inch, 0.09 inch is 2.3 millimeter. If you calculate it, then we have to repair the area or replace the area. Okay, that is about the bottom. Come to the shell, we have to calculate the T2. We have to check the T2. What is the T2? I told a minimum thickness in a corroded area is T2. Then what is T1? The lowest average of the vertical line in a corroded area. Then we have to calculate the T minimum using the 1 foot formula. Now, when you are calculating for the entire shell course using the 1 foot formula, you have to use a H minus 1 formula. If it is locally thinned area, then we have to use a H formula. What is mean by H? For entire shell course from that particular course bottom joint to the design liquid level. For locally thinned area, from the bottom of the locally thinned area to the design liquid level. That is the H. Then another one you get confusion is efficiency. If it is close to the weld, you have to refer the table, which year it was fabricated, as per which standard. But it is away from the weld, at least 1 inch or 2 times thickness away from the weld, you have to take efficiency is equal to 1. Clear? Then stress, we have to refer the stress table of the 53. First 2 courses, there is a separate value, and the third and the above course, there is a separate value. You should be careful which course they are asking. Another one, if the material is unknown, there is an unknown stress value also we have to do. Suppose material is unknown, you don't know the stress also. If they give tensile strength and yield strength, there is a formula 0.9 or 0.882 formula we have to use, whichever is the lower value you have to take. So this is about the shell. Now coming to the bottom. Okay. The purpose of bottom inspection is to check for the bottom corrosion. Where the bottom is corroded or not. See, the problem with the bottom is if you take a shell, generally, why shell is not serious in a tank is shell inside what we are storing inside the product oil. Most of the oils are non-corrosive. So inside there will be no much corrosion. And outside there will be atmospheric corrosion. From that we will protect from the painting, or if it is insulation, or we will protect it. So shell corrosion generally will be minimal. Shell corrosion is not a serious issue. But the shell corrosion, we can see the corrosion also if it is corroding outside. But the bottom, first thing we cannot see from on-stream inspection or external visual. So we have to go for an internal inspection to check the inside condition. Bottom condition, we don't know what is happening bottom side. Okay. How we will check the bottom condition and the inside condition? By doing the MFL. MFL can measure the corrosion on both sides. Only condition is the bottom plate thickness should be less than half an inch. Half an inch is 12.5. MFL or penetration capability only 12.5 millimeter. If the bottom thickness is more than 12.5 mm, it will not detect the bottom side corrosion. It will only detect a top side corrosion. Okay. Now this formula is particularly some MRT. MRT means it is not a minimum remaining thickness now. It is minimum remaining thickness next inspection. MRT is minimum remaining thickness, not now. Minimum now you can use a UT, you can find the thickness. The calculation is what should be the minimum remaining thickness at the next inspection. For that, first you have to check what interval you want to check. Then what is the minimum thickness in the bottom plate? Then you have to add both the corrosion rate, top and the bottom corrosion rate. So what is the formula? Minimum of RTBC or RTIP. So what is RTBC? The minimum remaining thickness bottom side after repairs. If you repair it, the thickness will increase. Then RTIP, the minimum remaining thickness internal corrosion, that is inside. So which one is the lowest value you have to take? That you have to take as a plate. Then OVAR is the next inspection interval when you are planning the next internal inspection. Then STPR plus VPR is the corrosion rate of the STPR is the corrosion rate of the top side. UPR is the underside. Okay, this terminology may be little bit. So STPR is the top side and the UPR is the underside. If we have effective cathodic protection, the underside corrosion rate will be 0. Okay, if you have a effective lining, top side corrosion rate will be 0. So just to give some clarity, just one moment, not yet. Okay. Now, so how much you understand? Again, I will just answer these 3 questions. Following applies to 116 to 117. 2 question only. Okay, no problem. RTBC 0.410. RTIP point. Is it readable online?
Yes, sir. Yes, sir.
Okay, okay, right. STPR 0.018 inch, UPR 0.005 inch. Using the data, I have calculated the MRT for the bottom plate after 7 years. Question number 116. What would be the MRT after 7 years if the owner decide to coat the tank bottom with the glass plate epoxy? Calculate this. RTPC 0.410. If you are not able to read, you can read it. It's clear only. Calculate this using that formula. Calculate both 116 and 117. See, it will not be same. If the owner decide to coat the tank bottom, this coating means the inside will be 0. There will be no corrosion. STPR will be 0. Lining, if you are going for lining, STPR is 0. Only we have to take UPR. So now how it will work out? 0.375 minus 7 into what is the UPR? 0.005.
Sir, small
0.34.
confusion.
Yeah.
Small confusion.
Yes.
They say they're given the bottom coating, sir. If it's a bottom coating for the tank bottom top side or bottom side?
Coating is always on the top side.
Coating is always on the top side.
Yeah, soil side we will go for only cathodic protection.
Okay, sir.
If it is cathodically protected, then it will be UPR will UPR will be 0. If it is lining or coating means STPR will be 0. Okay. So
Sir,
the answer will be
answer A.
Yeah, answer should be A, 0.34. Generally, this MRT exam they are not asking. If they ask, this is the way the question will be asked. Okay. And I told you the T minimum shell, they are giving much importance, T minimum. So we are just overlapping another 10 minutes the chapter for the last 1 hour we covered. என்ன புரியல சொல்லுங்க 7 into 0.018 plus 0.005 ரெண்டையும் ஆட் பண்ணிக்கணும். And STPR plus UPR formula பாருங்க. So you have to add a point C, both the correction rate you have to add 0.018 plus 0.005, then it will be 0.023, multiply by 7, then minus which are the lowest value 0.375 minus that value. So question number 116 we will get answer 0.214. Question number 117 is because there is a coating, the STPR is 0, only UPR 0.005 multiplied by 7. We have to minus from the 0.37.
Sir, from 650 and from annexure part, how many questions we can expect, sir?
Annexure question, there will be 3-4 questions.
From the whole 650.
Yeah, annexure C, there will be generally annexure C and H. External floating roof and internal floating roof together will have around 4 questions.
Remaining all not really important.
Remaining not very important, maybe 1 question.
Okay, sir. Sir, another thing is,
Yes,
how many generally there will be mathematical related questions, sir?
around 10.
Or because I feel
Open
comfortable.
book around there will be 4 or 5.
Okay.
Closed book there will be around 10. But I told you there will be around 4 to 5 questions remaining correction allowance, correction rate calculation. I started with that one.
Yes, sir.
And the West external inspection. These are from chapter 6, the next chapter.
Okay. So when you say close to book problematical question, which means that we need to memorize,
memorize. We should know what is meant by correction rate. How to calculate correction rate? I told you. T
yes,
previous minus T actual divided by number of years.
Yes, sir.
That formula. This is the same. You are already familiar with the 510 and 570.
Yeah. No, I'm asking like because this MRT formulas and the
MRT. These are the open book formulas.
These are the open book questions. Okay.
Only chapter 6 formulas are the closed book formulas.
Okay. Thank you.
Okay. Yes. After 7 years, what should be the minimum thickness? That is a MRT means minimum remaining thickness after 7 years. Now, we got, for example, first one we will take 0.214. 0.214 is not a problem. But if the thickness is coming less than 0.1, then what we have to do? We have 3 options. One option is coating. Because when you coat it, you can see the thickness is increasing 0.34. Second option is if you go for cathodic protection, then the thickness will further increase, the MRT. So either you can go for a coating to make 0 of the top side corrosion, or you can go for cathodic protection to make 0 of the bottom side corrosion. Suppose both are not possible, then what is the third option? What is the third option? I am telling the MRT minimum remaining thickness at the next inspection should be at least 0.1 inch. Suppose the calculated value, in this case it is okay, no problem. It is coming less than 0.1 inch. To make it 0.1 inch, you have to make top side by coating, top side corrosion will be 0, or by cathodic lining, bottom side corrosion will be 0. Anything we can do. Suppose both are not possible, what is the third option? Third option is reduce the inspection interval. Instead of 7, if you put 3 years, the value will go up. Inspection interval can be reduced. Formula inspection interval, suppose instead of 7 years, if you calculate, put 3 years, this value will go up. So we have 3 options, either top side coating or bottom side cathodic protection, or both are not possible, then we have to reduce the inspection interval. So we'll go back to the code book. Now you can see here, MRT is the minimum remaining thickness. So over RTBC, you can see STPR is the maximum rate on the top side. STPR is 0 for coated areas of the bottom. Then UPR is the bottom side. UPR is 0 for effective cathodic protection. Now, what should be the MRT? We have to follow this table. Generally, it should be 0.1 inch. MRT means the next inspection, it should be 0.1 inch. But there are 2 concessions allowed. If you have release prevention barrier, even 0.05 inch is allowed. 0.05 inch, 0.1 means 2.5 millimeter. 0.05 means 1.25 millimeter is allowed. When you have a tank bottom design, provided reduction of containment of bottom, that is a release prevention barrier. Or if you have a thick lining, reinforcer lining more than 50 mil, 0.05 inches, 50 mil, multiply by 1000, you will get a mil. Then also half of the thickness is allowed. Okay. See, what is the advantage of 0.05 means you can increase the inspection interval. Suppose 7 years it is coming 0.1. If you want 0.05, you can inspect after 14 years. So inspection interval can be increased. That is the advantage of this. There are other things. What I said, where this 0.1 inch is mandatory. If you take a bottom plate, this should be 0.1 inch. But I told you there are 2 conditions. It allows 0.05 also, half of this. One condition is when you have a thick reinforcement lining. Second condition is if you have a release prevention barrier. But in critical zone, 0.05 inch is not allowed. What is meant by critical zone? From the shell, 3 inch, 0.1 inch mandatory. Outside, the projection outside plate, 0.1 inch is mandatory. Critical zone also 0.1 inch is mandatory. Outside also 0.1 inch is mandatory. So outside projection thickness should be 0.1 inch. What should be the length? Outside projection length will be from the weld to 3/8 inch. Because these are the one we have seen mainly yesterday. Okay. Then another one, annular bottom plate thickness. So what should be the annular bottom plate thickness? I told you, if the specific gravity is less than 1, you have to follow this table. And if the specific gravity is 1 or greater, you have to follow APA 650 table. Others are not so simple. Is it okay, Sriram, this much?
Yes, sir. Yes, sir. Sir, sir, 0.1 is the minimum. If it's going to be 0.05, if it is have a release prevention, which means that the diagram, the first day you played a video that when it's the inlet pipe, when the inlet pipe is flow is pouring, it doesn't pour on a single direction, it's a multiple direction. So that's the one you're talking about, right, sir?
Okay.
And what the last one is reinforcement lining. Are the lining means it's on the top side, sir? But the
top side lining, if the thickness is more than 50 mils, that is called a thick reinforced lining. Then it can be 0.05 inch.
How many mils, sir? Thickness lining?
50 mil. 0.05 multiplied by 1000 will result in 50 mil.
Okay, sir. Okay, sir.
Okay, so we will start the chapter 5. Very simple chapter, brittle fracture considerations. But the exam, they are asking 3-4 questions in this chapter. Generally, 3 questions are asked in the exam. So APA 650 exam, they are giving 650 exam, they are giving importance for this chapter. So how to find out brittle fracture? First, we will go to the exemption curve. Please go to the page number 5-3, exemption curve for tanks, constructor of carbon steel of unknown materials. If you don't know how the material is carbon steel, then how to find out? You can see the x-axis, it is given in shell thickness. Shell thickness is, it is a nominal thickness. This is the temperature. Now, you can see here, safe for use. Here also safe for use. Okay. What is the meaning of this exemption curve is, when the thickness is less than 0.5 inch, what is the temperature here given? 0 degree Fahrenheit up to 0, it is safe for use. There will be no brittle fracture. That is the first understanding of the curve. When the thickness is less than 0.5 inch up to 0 degree Fahrenheit, there will be no brittle fracture in carbon steel material. Point number 1. Second one, when the thickness is more than 60 degree, you can see this horizontal line. When the temperature is more than 60 degree Fahrenheit, what is the thickness here given here? 2 inch. That is the maximum thickness we are using in the shell. Maximum thickness is generally 1.5 inch only. Yeah, 2 inch also, there will be no brittle failure. So 60 degree Fahrenheit, there will be no brittle fracture. Less than, if the thickness is less than 0.5 inch, up to 0 degree Fahrenheit, there will be no brittle fracture. For other thickness, let us check. For example, thickness is 0.6. Which temperature is safe for use?
Up to 40. Up to 40.
So it should be, so here the 0.6, this is 0.6, 0.7, 0.8, 0.9, 1. So if you take 0.6, it is a little bit more than 40. So I can 45 degree Fahrenheit. If it is more than 45, it is safe. For example, thickness is 0.7. What is the temperature? Almost less than 50. Less than 50. So 48, 49 like this. Okay. If we take 0.8, what is the temperature? More than 55. Exam question will be open book. They will ask like that. What is the safe temperature to avoid brittle fracture for 0.7 inch thickness material of unknown material? எங்க கட் ஆகுதுன்னு பார்க்கணும். அதை விட ஹையரா இருக்கும். because this area is only safe area. Suppose if it is following here, we have need the additional assessment required. See, what is the additional assessment? I told yesterday class also how I know the material is a recognized toughness. First thing, if you know which year it was fabricated and you have the records, originally the tank was impact tested, then you can say there will be no brittle fracture. Second point, suppose you don't know, you can go for a coupon cutting. Cut a plate from the tank shell, send for impact test. If it pass the impact test, then it will affect. Sorry, it is considered as acceptable. Now, third one is going for a hydro test. Suppose you have a doubt, if you go for hydro test, if it withstand hydro test at the winter session, suppose you have to do on a colder condition, hydro test, if it not fail during hydro test, during service, it will not fail. These are the 3 points we have to check. Another one important in chapter 5 is what is meant by severe service. When a tank is considered under severe service, only 2 conditions. When a stored product specific gravity is increased, for example, before you stored a product with specific gravity 0.8, now you want to store a product with 0.9, then it is considered as a severe service. Second one, design temperature is reducing. Suppose that before the temperature, we use some heating, temperature was different, and now the temperature is less than the previous temperature, then it is considered as a severe service. So severe service means increase in the specific gravity or reduction in the temperature, stored product temperature. If you are going for severe service, you have to prove that the tank will not become brittle under severe service. How you will prove that? Hydro test. Okay, so this is only in chapter 5. Very simple chapter. Generally 2 to 3 questions will be asked, very easy to score. Okay, so please we'll go from the chapter, starting of the chapter. Section 5, highlight the 5.2.2. In all reported incidents, tank failure due to brittle fracture, failure occurred either shortly after erection during the hydrostatic testing or on the first filling in cold weather, after a change to lower temperature service, or after repair alteration. So when there is a possibility of brittle failure, first hydro test during construction, first filling in cold weather, or change to the lower temperature service. This experience there shows that once a tank has demonstrated the ability to withstand the combined effect of maximum liquid level and lowest operating temperature without failing, the risk of failure due to brittle fracture with continuous service minimal. It will not fail in the service. Highlight 5.23. Any change in service must be evaluated to determine if it increases the risk of failure due to brittle fracture. In the event of change of more severe service, this bracket is important. What is meant by more severe service? Operating a lower temperature or handling a product at a higher specific gravity. Highlight this too. Operating to lower temperature or handling a product with higher specific gravity. So this and this. Okay, necessary. It is necessary to consider the need for a hydrostatic demonstrate new more service. Then how to take the assessment? Highlight the 534. So we'll go for step 1. The tank meet the requirements of 657th edition later. Then this one. For the purpose of this assessment, hydro testing demonstrates the fitness for continuous service. That line is important. Once it passes the hydro test, it is considered as a fitness for service. It will not fail during the service. With the minimum risk failure due to brittle fracture, provided that all governing requirements of repair, alteration, reconstruction, and the change in of the standard. Then please, this is not important. Please go to the page number 5-3. Step 4. If a tank shell thickness is no greater than 0.5 inch, the risk of failure due to brittle fracture is minimal. That is important. When the thickness is less than 0.5 inch, it will not fail brittly. Then 5.36, step 5. No known failures due to brittle fracture have occurred when the shell metal temperature is 60 degrees Fahrenheit or above. When the temperature is more than 60, there will be 60 and above, there will be no brittle. Similar assessments, again, brittle fracture can be made by increasing the metal temperature by heating the tank component. You can use the heaters also inside. Then this is, I forget to tell, stress. Industry experience and laboratory tests have shown the membrane stress to tank shell plates at least 7 KSI required to cause failure. We need at least 7 KSI stress. 7 KSI means 7,000 PSI to cause brittle failure. That much load should be there in that area. Then only it will fail brittle. Okay. This is again closed book question. So this exemption curve is a open book question. I told you how to interpret the curve already. Then please go to the next page. Step 9. An equation can be performed to establish a safe operating envelope. The evaluation may show need to re-rate it or operate differently, several operations. So now, how to avoid the brittle fracture? Suppose you think just opposite. Reduce the level, liquid level. Change it to the lower specific gravity product. Increase the temperature. Just say, restrict the liquid level, restrict the minimum metal temperature, change the service to store the product with the lower specific gravity. Combination of items. So suppose you want to avoid the severe service means you have to go for reverse. That's all. Chapter 5. Close book question.
Step 7, step 8 banala, sir.
Vanda. Yes. அதாவது பிரிட்டில் ஆகுன்னு டவுட் இருந்தா ஆகாம இருக்குன்னா டெம்பரேச்சர் இன்க்ரீஸ் பண்ணணும், இல்லை லிக்விட் லெவலை குறைக்கணும், இல்லை ஸ்பெசிஃபிக் கிராவிட்டியை குறைக்கணும். இது கேட்குறீங்களா? இதுல என்ன இருக்கு? லெஸ் தென் 0.5 சேஃப் ஃபார் யூஸ். எனி டெம்பரேச்சர் அப் டு 0 only they can. More than 60 degree Fahrenheit safe for use. Any thickness, because thickness up to 2 inch only we are using. But in between this 0.5 to 2 inch, only this area is changing. This is the changing curve. So 0.6, it will be more than 45. I told more, it is crosses 40. And 0.7, I told it will be 50. 0.8, if we take, it will be 55. And 0.9, it will be 60. So 0.9 and above, 60 degree Fahrenheit. Safe for use. The graph engana cut பண்ணதுன்னு பாப்போம். If they ask 0.5 to 0.9, then you have to follow this line. Once it reaches 0.9, 60 degree is safe for all thickness. 60 degree Fahrenheit. என்ன புரியல சொல்லுங்க. 45 na 1.5 inch. அப்பனா 60 degree க்கு மேல safe for use. Below 60 na you have to go for additional assessment. இந்த year zone 55 க்கு வந்து 0.8. இது 0.8 thickness 55 degree Fahrenheit மேல ஆப்ரேட் ஆகுதுன்னா நோ இம்பாக்ட் டெஸ்ட். அவன் இம்பாக்ட் டெஸ்ட் பண்ணுன்னு சொல்ல அடிஷனல் அசஸ்மெண்ட் அப்படின்னு சொல்லுவாங்க. we have to check ஹைட்ரோ டெஸ்ட் விஸ்டாண்ட் பண்ணுதா அப்படின்னு பார்ப்போம். இது இம்பாக்ட் டெஸ்ட் செக் பண்ணுறதுக்கு இல்லை, பிரிட்டில் ஃப்ராக்சர் ஆகுமா இல்லை. ஓகே, now we will go to the chapter 6. Chapter 6 will have around 6 questions. Yesterday I started with the calculation. What is RCA, remaining portion allowance? What is N, portion rate? So first I will recall the shell inspection interval. Okay, then we will go to the bottom. Bottom is separate again. First let me start with the shell. You remember I told you shell, there are 3 types of inspection we are doing. Routine in-service inspection. Who will do? It will be done by operator. From the ground level, he will check. What is the frequency? Every month. Then external visual inspection by AP inspector. Check all levels of the tank. What is the rules for this? RCA by 4N. RCA by N is actually remaining life. Okay. RCA is the remaining portion allowance. N is the correction rate. So RCA divided by 4N or 5 years, whichever is less. For UT thickness measurement, it will be done by either the examiner or inspector. Inspector also can do it. What is the rules is, if the correction rate not known, 5 years. If the correction rate is known, RCA by 2N or 15 years, whichever is less. Okay. First, let us complete the shell. There will be calculation based on this. Okay. They will give some data. We will do some calculation later. So please take the code book. The purpose of this inspection is to assure the continued tank integrity. Inspection other than defined shall be directed by the authorized inspector. Close book question. The purpose of this inspection is to assure the tank integrity. That line. Then 6.2.2 last line. See, the interval between the inspection of tank from first line should be determined by service history unless special reason indicate the earlier inspection. A history of service of a given tank, similar service should be available. Then highlight the last line. On-stream, non-destructive examination method shall be considered when establishing the inspection frequency. Sometimes, you remember I told you yesterday again, if there is a conflict between the 653 and the local jurisdiction, which one you have to follow? Same, here also same. Suppose the local jurisdiction says you have to inspect every 3 years, then you have to follow that. Okay, so highlight this one. Jurisdictional regulation in some cases control the frequency and interval of the inspection. This regulation may include, this is open book question. The regulation is based on the second line. Vapor loss requirements, seal condition, leakage, proper diking and repair procedure. That line is important, open book question. So local regulation based on the vapor loss requirements, seal condition, leakage, proper diking and repair procedures. Then we'll go to the routine in-service inspection. The external condition of the tank shall be monitored by close initial inspection from the ground of routine basis. This inspection may be done by owner-operator personnel, can be done by other than authorized inspector. So routine in-service, no need the authorized inspector. Then personnel performing this inspection should be knowledgeable of the storage facility of the tank and the characteristics of the flood. They should have the knowledge. Now, this is a closed book question. The interval of such inspection shall be consistent with the conditions at the particular site, but shall not exceed 1 month. Then what they will check? Highlight this one. The routine in-service inspection include the visual inspection of tank exchange service. Then highlight this one. Evidence of shell distortion, settlement, corrosion, condition of the foundation, paint coating, insulation system, and the upper should be documented and a follow-up action by the authorized inspector because it will be done by the operator. Now, next one, external inspection. Your printout, there is a missing. The numbers are missing. The RCA, N, they are missing. But we have edited now. We will give you the soft copy. Okay, you write it, no problem. We will give you the soft. Yeah, RCA, you have to write it because it is missing because we noted lately. N, 4N. Yeah. All tanks shall be given the visual external inspection by authorized inspector. See, last time they asked 3 questions in this calculation. This inspection called an external inspection and must be conducted at least every 5 years or RCA by 4N. Please write in remaining correction allowance. Here it is there where RCA is the difference between the measured shell thickness and the minimum required thickness. That is called remaining correction allowance. And N is the shell correction rate in mils per year or you can take inch per year. Please remember all the units should be same. Remaining correction allowance, if you are taking an inch, this also you have to take it in inch. That is mil, this also mil. Okay. Whichever is less, tank may be in operation during this inspection. So please write in the hard copies because this is missing in printout. The soft copy is there. Okay. This one. Now, RCA by 4. Okay. Now, next one. Insulated tanks need to have the insulation removed only to the extent necessary to determine the condition of the exterior wall of the roof. So, during that, no need to remove the insulation completely. External ultrasonic thickness of the shell can means of interpreting rate of uniform general corrosion while the tank is in service and can provide an indication of the integrity of the cell. Then when used ultrasonic, this is important. When corrosion rate is unknown, the maximum interval is 5 years. Suppose you don't know the corrosion rate, 5 years. Corrosion rate may be estimated from a tank in similar service on thickness measurement interval not exceeding 5 years. Then again write here, when the corrosion rate is known, the interval shall be RCA by 2N. Write this. RCA is the difference between the measured shell thickness and the minimum required thickness. And N is the shell corrosion rate in mils per year or 15 years. Okay. Let us work out one example. So I am writing the year, thickness, (2010), the thickness was measured at 0.5 inch. 2015, the thickness was measured at 0.470 inch. 2020, the thickness was measured as 0.430 inch. T minimum is equal to point. Yeah, all are this. No. 1 minute. 300 inch. Okay. So if this is the data given you, you have to calculate the when you have to conduct your first routine in service. Visual external. UT thickness. So please calculate this. Okay, how to calculate it? First, we have to calculate. So this one is very simple. For a routine in-service inspection, there is no formula. 1 month. Very simple. For this, we have to first calculate what is RCA. So what I told RCA, this is the difference between these two readings. So 0.430. Yes, please. Okay. Minus 0.300. That is T actual means the last reading. Because exam question, they will not mention T actual, all these things. You have to find out which is the T actual. This is the T required, only T minimum they have given. So 0.43 minus 0.3, that will be 0.13 inch. Then we have to calculate the N. What is the N? Corrosion rate. This is the difference between this last two readings divided by number of years. So 0.470 minus 0.430 divided by how many years? 5 years. 0.470 minus 0.43 divided by 5. So it is 0.008 inch per year. Now, first one, visual external RCA by 4N or 5 years. So whichever is less. So RCA by 4N, 0.13 divided by 4 multiplied by 0.008. So we will get 4 point some years. Correct? So answer we will get 4 years. This is the answer. UT thickness RCA by 2N or 15 years. So if you work it out, RCA by 2N, 0.130 minus 2 into 0.008, you will get 8 years. So 0.13 divided by 2 into 0.08, 0.008. So 8.125 years, 8 years. So this is the answer. This is the way you have to work it out. So visual external we have to conduct in 4 years. Generally, it will be double because RCA by 4 and RCA by 2 and it will be almost double. You can round it always on lower side. Years you have to round it all. It is coming for 8.125 something it is coming. So you can make it 8 years. That is a maximum inspection interval allowed. If anybody online don't understand this formula, please ask. I will explain again. Yeah, they will. See, we have to take purposely. I give 3 readings. The first reading doesn't matter. Only last 2 readings we have to take. 2010 and 2015 and 2020 only we have to take. Last 2 readings only we have to take. That's why I told. T minimum actual T minimum point last reading the actual. Kadasi reading the actual. This one 0.47 is the previous.
Hello.
Yes, please.
In this, there is no long-term corrosion rate and
No,
short-term.
it is no. This is
The
different
last
from
two,
510, 570. It is different. 653 is different. Only last 2 we have to take. Only T previous minus T actual. Actually, the formula is not given in 653. This is given in 575. Okay.
Okay. Only the last 2 we should consider. That's
yes,
it, right?
Yes, right. Exactly. Okay.
Is there any internal inspection interval, something like that?
Which one?
Internal inspection interval.
Internal inspection is given in for bottom. We will see later. This is for the shell. Shell, there is no internal inspection mandatory. Okay, what code says? Internal inspection is only required for the bottom. But suppose if you are going for internal inspection, you have to shut down the tank. You have to clean the tank completely. That time you can do this inspection also if possible. But if there is no shutdown, you can see this one from outside only. Okay. Any other question, please? Right. So this, there will be around 3 to 4 calculation exam they will ask. Okay, we'll go back to the code book. Now, cathetic protection survey. Just to work it out, we have more calculation in your question bank. Okay. Cathetic protection survey. Highlight this one. Where exterior tank bottom portion is controlled by a cathetic protection system, periodic surveys of the system shall be conducted. Then this was latest asked exam question. Who will review the survey result? Owner operator shall review the survey result. Very important. The survey result shall be reviewed by the owner operator. Very, very important. Last exam, this question was asked in closed book. And the next one also important. Owner operator shall assure the competency of the personnel performing surveys. Now we will go to the internal inspection. So this is shell we have completed. Internal, a simple rule. See, I am telling many rules. 655. What is 655? What is I told 655? 6 mm, 5 mm, 5 mm. It is 650 bottom shell roof. 2.5, 2.5, 2.3. 653. Same one more rule in internal inspection is 10, 20, 30. First internal inspection should be carried out in 10 years. If we have additional protection, there is a table is given, the interval can be increased. Okay, but there is, if there is no release prevention barrier, maximum interval is allowed is 20 years. If you have release prevention barrier, maximum interval allowed is 30 years. So bottom will follow the 10, 20, 30 without any additional. What is meant by additional? You can see a table. Add to initial interval. Okay, so page number 644. Suppose generally internal inspection is 10 years. Suppose if you have fiberglass reinforced lining on the product side, you can add another 5 years. Instead of 10 years, we can make it as a 15 years. If you have a internal thin film, you can add another 2 years. If you have catalytic protection soil side, you can add another 5 years. You can add like this, go on adding. But this cannot be more than 20 years without a release prevention barrier. With the release prevention barrier, it cannot be more than 30 years. You have to, you can add it, all these things. Whatever you have additional safety features, you can add it. இது புரியுதா? So again I will repeat, internal inspection is used to check the condition of the bottom. Without any additional 10 years is the minimum interval we have to do. Suppose you are additional, you have to add whatever you are having, you have to add. But the adding period cannot be more than 20 years. Suppose it is coming 25 years, you cannot do 25. Maximum allowed is 20 years without a release prevention barrier. Suppose it is coming 40 years, but the maximum allowed is 30 years with the release prevention barrier. So what are the addition? If you have FRP lining on the product side, as per 652, 5 years you can add. This is an open book question, regularly asked open book question. Installation of the internal thin film coating. If you have thin film coating, you can add it 2 years. If you have catalytic protection on the soil side, you can add 5 years. If you have release prevention barrier as per 650 annexure, you can add 10 years. This one is latestly asked. Suppose you have an extra thickness at the bottom. The thickness is more than 0.25 inch. There is a formula here. Initial bottom, suppose you have 0.5 inch. 0.5 divided by minus 0.25 divided by correction rate. How many years you are coming, you can add it. So there is, they work out here. For example, if you have a 5 by, highlight this one. Last exam, this was asked. How to add the credit for the extra thickness. Highlight this one. For example, if we have a thickness 5 by 16 inch, what is 5 by 16? Calculate it, 5 divided by 16. So see, it is given 0.3125. What is the actual record? 0.25. So you have extra thickness. 0.3125 minus 0.25 divided by the correction rate they will give in the exam. Then you are getting 4.2. This also you can add it. Extra thickness, you can add another 4.2 years. Then if you have a bottom construct of stainless steel, you can add 10 years. Extra 10 years you can add. This formula, see wherever you marked with a blue color, latest exam questions. Okay. Other than we marked with that. Okay, now this is recently asked. So what are the addition? If you add this one, 5 plus 2, 7, 7 plus 5, 12, 22, 32. So it will come here 4 years, for example, 32, 36 years plus 10, 46 years it will come. But we cannot have all actually. So 46 now, but what is the maximum allowed without a release prevention barrier? 20. With the release prevention barrier, that's all. Next one is whether internal inspection is mandatory to check the bottom. Without internal inspection, how we will check the bottom? Internal inspection means we have to completely clean the tank, drain the tank and clean the tank. Suppose only thickness measurement you want, you can use robots. Robotic thickness measurements are possible. AUT. Robot can do the AUT and we can thickness measure. Another condition is, suppose you have a small tank and the small tank is kept on some high area, you can go underside also and check the correction of the internal correction. You can do UT from the bottom side also. Okay. So these are the key points. So please highlight this one. Internal inspection. Highlight this one. The internal inspection is primarily required to do as follows. A. Ensure the bottom is not severely corroded or leaking. Highlight this one. Page number 6-2. Last slide. So why we are doing internal inspection? Check it is not leaking. A. Open book question. B. Gather the data necessary for the minimum bottom thickness and the shell thickness assessment. If you are going internal, you can measure the shell thickness also. And tank bottom settlement to evaluate the tank bottom settlement. So tank bottom settlement. These are revised in 18. By 18 means this was revised in the 2018 revision. 19 means this is revised in the 2000. They changed the wordings. Okay. Now 642. The authorized inspector shall supervise, very important, or conduct a visual examination and assure the quality and the completeness of the NDE results. That is important. So either authorized inspector should conduct the NDE or he supervise the NDE. That line is important. If the internal inspection is required solely for the purpose of determining the condition integrity of tank bottom, the internal inspection may be accomplished with the tank in service replacing various ultrasonic robotic thickness measurement and on-ship inspection method. That also important. Suppose only to check the integrity thickness measurement, we can use a robot also. That's also important. That 5 lines are important. Now inspection interval. When any new edition comes, within 5 years, we have to use this edition. For example, the last edition was revised in 2012. So we are within 5 years, you have to change it to the latest edition. That is open to question. For existing tank, planner shall review the internal inspection interval and be in compliance with the section within 5 years, the date of first publication of January 2012. Then this is what I said, 64211. The interval from initial service date until the first inspection shall not exceed 10 years unless a tank has one or more late prevention, detection, corrosion mitigation, or containment safeguards listed in 6.1. So generally 10 years, first one. The maximum initial inspection interval shall be based on the 10 years plus the increment levels, which are cumulative. And this one is very important. The initial internal inspection interval shall not exceed 20 years for tank without release prevention barrier and 30 years for tanks with the release prevention barrier. Then this table is important. I told you, if you have excess thickness, how to calculate the odd at the inspection interval. So thickness more than 0.25 minus 0.25 divided by the corrosion rate. Corrosion rate they will give in the question if they ask this question. Now you can see here. Suppose you have, they are given example. Maximum initial inspection interval is 10 years initial, 5 years FRP lining, 10 years release prevention, 4.2. So total 29, but it cannot be more than 29 is allowed because we have release prevention barrier. As an alternative to establishing the interval, the initial interval can be established by the RBI. What is meant by risk-based inspection? Actually, RBI is not very important for 653. Just I will briefly explain what is RBI. So there is a formula for risk. Risk is the probability of failure multiplied by a consequence of failure. So P means probability. C means consequence. Probability means what is the chances of failure. Consequence means if there is a leakage, what will be the effect? How will affect the person's environment, equipment, all these things. Now, but no need to go much detail because it is not important for exam. So RBI is a separate methodology. If you are going RBI, we will not follow the 653 rules. You can increase the inspection interval more than 653 or decrease the inspection interval based on the risk involved. Risk means suppose there is a leakage, how it will affect the environment and the public. Okay. I will not go much detail because it is not important for exam. 510 570 RBI plays an important role. Okay. This assessment may establish the internal inspection interval exceeding 10 years, but shall not exceed 20 years for tanks with the without release or 30 years with the. Suppose if you are conducting RBI, even without this additional, you can without this any of this additional, we can go up to 20 years. But without release prevention barrier, if you release prevention barrier, we can go up to 30 years RBI. Now, when you are conducting RBI, this is open to question. If an RBI assessment has been performed, the maximum initial interval inspection does not apply to tank scoring the following. This is the open to question. Highly viscous substance solidified at temperature below 110. Any substance that is not identified by the hazardous owner operator will not adversely impact. Just to mark it as a open. Then these are not important. Please go to the next page. An RB assessment shall consist of a systematic evaluation of both the likelihood of failure and associate consequence of failure in accordance with 580. RB assessment shall be thoroughly documented. Likelihood, probability, both are same. I write POF. LOF was a older terminology. Likelihood, both are same. Close book question. And the RB assessment shall be thoroughly documented, clearly defining all factors contributing to both the likelihood and the consequence. That is important. Then this is who will conduct the RBI. The RBI assessment shall be performed by a team including inspection and engineering expertise, knowledgeable in the proper application of 580 principle. That is important. The RBI assessment shall be reviewed and approved by a team as above, and will not exceed 10 years more often if warranted by the process. That also important. Every 10 years it will be reviewed by the expertise team. Then we are using RBI, spot UT shall not be used. That also important. Correction rate from low inspection such as spot UT shall not be used in the RBI process. Then please go to the page number 6-7. Alternative to internal inspection. Suppose you have access on the bottom side. You can go below the bottom. Suppose the tank is lifted, then we can do inspection from the outside. In case where construction size and other aspects allow external access to the tank bottom, determine the bottom thickness. External inspection in lay of the internal inspection is allowed to meet the data requirement. That is important. You can do external inspection to check instead of internal inspection. Records. Now, who will maintain the tank records in service? Owner operator. What are the different type of records? 3 types of construction, inspection and repair alteration history. Highlight this one. The owner operator shall maintain a complete record consisting of 3 types: construction record, inspection history, and repair alteration history. So what will have inspection history, repair alteration? Highlight repair alteration last line. These records should include the result ends experience and coating lining. That line is important. Inspection record should include the coating lining also. Yeah, last line. Yeah, CBQ. Then we will go to the recommendations. 6932. It is the responsibility of the owner operator to view the inspection finding and recommendation, establish a repair scope. Typical timing considered for examples of repair is, highlight the A and B. Prior to returning to service, repairs critical to the integrity of the tank. Bottom. So before returning to service, you have to critical repair should be completed. After tank is returned, minor repairs and maintenance activity we can do it. Even in service we can. Open to question. The next page 6-9, non-destructive examination. The result of any ND work cover must be considered in the evaluation of the tank by an authorized inspector, because inspector is responsible for the ND. Right. That is the close question. Okay. So we have completed now 6 chapters. We'll go review these questions, then we will go to the next one.
Sir,
Yes, please.
sir, like a vessel, do we have any specific rule that so and so specified here we need to do internal inspections are in tanks?
No, there's nothing like this.
So just in case, like if there we couldn't have a possibility of doing internal inspection at all for the whole tank period, what is going to be the consequences or result, or do you have any kind of
No, internal inspection is used to check the integrity of the bottom.
Yes, sir.
If you know that bottom is in good condition, no need internal inspection.
Okay. So what
my question is, if you are not doing internal inspection for a longer period,
yep,
bottom may leak.
Okay. So how do we decide? Because on all this situation, we are saying that 10 years for the inspection. But my question is, like we don't have access of going underneath the tank, and
Okay.
and we don't want to unfill the product from the tank. So what are the other possibilities? So how
You
many
can go
years?
for a UT, robotic UT thickness measurement. When the oil is filled with oil, we can send the robot inside
Okay.
by remote operating. They can
You mentioned.
yes, with the
Yes, you
oil
mentioned.
filled.
Yes, sir. You mentioned me that, but is there nothing is possible? Like, is there any specific time that I need to unfill the product from the tank and need to go for?
When the tank is severely leaking, we have to unfill. That's all.
Okay.
Okay.
But when you're severely leaking, means we get only the evidence from the foundation. That's the time you're gonna get the.
Yes. Foundation, and you can find out. See there. That's why we are using a channelizing outside. Any leak will come outside. They will monitor how much it is leaking. They know what is the level in the tank, how much it is reducing. Suppose if it is severely leaking, then we have to empty the tank and go for repair work.
But if it's going to be in a hot weather condition, they're going to be like a reduce in liquid level because of the evaporation.
That they know all these things. Okay, the leaking you can monitor easily.
But how about if it's going to be what do you say, the inert gas or the toxic substance which is going to be I'm just
this code, it talks about only oil storage tanks. This is not talk about that gas storage tanks.
Okay.
Gas storage tanks, we have separate rules from 620.
Okay, sir.
Okay, right. Okay, thank you.
Thank you, sir. Because I can't ask this question to someone else, so I thought.
Okay, right. Okay, no problem.
So I thought just want to ask.
Right. So let us review chapter 4, because yesterday I think we reviewed up to chapter 3, right? Okay, try to answer it. Yes, read.
Then must have an evaluation to determine the suitability for use be conducted.
Okay. So what is the answer? When must an evaluation determine suitability for just to hold on, I will. When must 1 minute? I will go to the online review. No, online review. I will go online review, so it will be easy. Okay. 53. What is the first question? When must an evaluation? Okay, just 1 minute. I'm taking. No, it will not work. I will check which question it starts from. 1 minute. 1 minute. Start from 172 because it's not arranged in the order. Okay. Right. Yes, please.
Then must have an evaluation to determine the suitability for container use be conducted.
Okay, what is the answer? Answer is A. Tanks shall be conducted. Sorry. Okay, next.
Areas that
Ah.
are areas that are fitted shall be evaluated to
Hmm.
determine.
Likelihood of through pitting occurring prior to next scheduled inspection. Just to follow this, these are closed book question. So next.
The roof gets corroded to an average thickness of less than dash inch in that any gas wiring user shall be treated as 100 square.
So answer is 0.09 inch in 100 square inch. Okay, each 10 question. Yeah, next.
Instead of expecting roof support members shall be accepted.
Okay. Just to check this, who will accept it? Method of instructing roof support members shall be acceptable. Give the correct answer. Okay. Storage, where it is given. 4.3.1. The evaluation exists to conduct a storage tank and shall include the analysis of design condition, thickness. Okay. Tank shell, this is the roof. They are asking roof. What is the question here? Inspecting of roof support members. Roof support members. Roof support structure and roof junction will be evaluated. Which one? Okay. Shall be, yeah.
Roof support member after final shall be inspected for soundness by a method acceptable to the responsible inspector. 4.2.2.1.
4.2.2.
First line, sir.
Okay, roof supports member shall be a responsible inspector. Okay. So answer is responsible inspector. B. That's why I told you, don't just answer it. Check this. Okay, next.
During the inspection of during the inspection of fixed roof support members, particular attention must be given to
The next line. Take the code from the chapter 4. So it is covered continuously, I think. Maybe it's a little bit jumping. So when you have to give particular attention, so it is here severe internal corrosion of pipe columns. You can see here particular attention should be given. Same 4221. Particular attention must be given to possibility of severe internal corrosion of pipe columns. Corrosion may not be evidenced by the external visual inspection. Page number 4-1. Okay, so answer is B. Okay. Yeah. Next. Yes, please.
the operating temperature is changed to a lower temperature than the original case. The requirements of the which standard for the lower
Next page. The answer will be next page. Lower temperature operation. Which standard you have to follow? Huh? Current applicable standard. We have to follow the current applicable standard. Current applicable standard means the latest revision of the code. Okay, next.
evaluation of existing floating roofs shall be based on the criteria of
Okay, evaluation of existing floating roof. Then the same page, there is answer. Annexure
C.
C for external floating and annexure H for internal floating roof. Okay, right. Yeah, that's the entire paragraph you can see. Okay, next.
An APA standard or recommended practice must be used for evaluating the effects of this partial
Vacuum, partial vacuum, same page. There will be there partial vacuum. Annexure, annexure 5. V adu. Annexure V. Okay. What is the number? 6 point? 4 point? 4.2.4.2. Okay, right. Next.
above Above what operating temperatures are AP standard 650, appendix M, be considered before changing.
So above 200 Fahrenheit, you have to use appendix F. Okay, 200 to 500. Next.
The evaluation of the existing tank shall be conducted by.
First line, next page, storage tank engineer. It should be conducted by this next page, first line, top, storage tank engineer. Next,
Calculate the critical length of the following shell course of in a tank diameter 150 meters.
see, in a shell in a locally corroded area, tank diameter 150 feet, least thickness measured 0.2 inch. So what is the formula for critical length? Critical length L is equal to 3.7 square DT2. So D they have given 150 feet to calculate it. Yeah. See, D22 formula you have to remember. One 3.7. So first you have to take square root of DT2. Diameter is 150 into, yeah, 0.2 multiply by 3.7. $20.26 it will come. See, don't put first 3.7. You have to first find out the square root of 150 multiplied by 0.2. Then we have to multiply by 3.7. You will get answer 20.26. Okay. Next.
Of the following, which is not an option available to the owner operator, if it is not possible to satisfy the requirements or minimum thickness calculation for a welded tank.
Repair damaged area, it is allowed. Reduce the allowable liquid allowed. Repair tank also allowed. Reduce the fill rate is not allowed. Fill rate will not affect that. See, which of the sheet, which is not an option available if it is not possible. Suppose the minimum thickness is less than the required thickness. What you have to, either you have to reduce the liquid level, or you have to repair the area, or you have to repair the tank. This is not allowed. We cannot reduce the fill rate. Fill rate will not allow. Okay, next.
Out of roundness, buckled areas, flat spots, and peaking and banding of welded joints are all examples of
shell distortion. These are the examples of shell distortion. Okay, next.
The maximum critical length allowed in a locally thin area is
40 inches. It cannot be more than 40 inches. 3.7 square root of DT2, but not more than 40 inches. Next.
In shell corrosion evaluation to determine the lowest average thickness T1 averaged over a length of L, what is the minimum number of readings to be taken over length L?
Minimum how many readings we have to take? 5 readings we have to take. 5 vertical lines. Okay, next.
What should be done with cracks beside the bottom?
Shell to bottom cracks are not allowed. We have to repair it. These cracks can be sealed with caulking, no. This bit can cover old pass, no. Critical and tank must be no. The crack and shell was critical and shall be removed and well repaired. So we have to remove and repair it. Next.
Internal fitting and fitting rates in the anticipated service, corrosion of weld joints, weld and heat effects. Weld joint cracking history and stresses placed on the bottom plates by root support loads and shell settlement are all examples of process of what type of.
Check this. Internal pitting and pitting rates in anticipated service. Where it is there? So internal fitting. Huh? Yeah, where it is given? 4.4.2. Okay, causes of bottom failure. You can see here, internal pitting rate, correction of weld joints, cracking history. They all is a causes of bottom failure. Okay, this all causes of the bottom failure. Okay, next one.
Widely scattered pits may be ignored, provided
So what is the two condition? No pit depth results in the remaining less than the one half of the condition. That is one. The sum of the dimension length does not exceed in the 2-inch height. Both A and B are correct answers. Okay. Next.
of the following what has historically not been a cause of bottom.
So what is the not cause of bottom failure? We have to check the same list. That list only, bottom failure list. There is a list 4.4 point something. Non-homogeneous fill under rock gravel foundation pads. Inadequate inspection frequency. That is not the reason. Yeah. Next.
In a corroded area, shall the evaluation criteria for continued operation is
What is the condition? The value T1 shall be greater than or equal to T minimum. The value T2 shall be greater than 60%. Any correspondence, all of them. These are the conditions. 4.3.3.2. 3.3.2, you can see these conditions are given. These three conditions are given in here. 4.3.3.2. 3.1. Here. 3. So 4 point. This one. The criteria for what is the number? This is 4.3.2.1. Okay, 4.3.2 actually. This value shall be greater than T minimum here. Right. Next. So this is the height. I think we calculated yesterday. 1985, 50 feet. We calculated. Leave it. Then this also we calculated. Okay, next 193.
unless a stress analysis is performed, what is the minimum thickness of bottom plates in the critical zone?
So what is the minimum plate of the particle for critical zone? Smaller of half of the original plate or 50% of the lowest, but not less than 1 inch. Okay, where it is given, you can see the bottom plate in the critical zone. Yeah. The bottom plate thickness, right? Here 4.4.54. 4.4.54 you can see. Unless the minimum bottom plate in the critical zone is smaller of 1/2 of the original bottom plate or 50%, but it shall not be less than 0.1 inch. Next one.
In repairing internal fitting for the extension of the service operating period, the repair shall be by any of the following methods, except
Pit welding, we can see overlay welding, lap patching, bracing is not allowed. You can guess it this out. Okay, next.
the thickness of the bottom plate projection beyond the shell, measured at the toe of the weld of the outside bottom to shell fillet weld, shall be not less than
0.1 inch. So outside projection shall be at least we should have 0.1 inch. Next.
the projection of the bottom plate beyond the toe of the shell to bottom weld shall be at least.
How much proportion? 3/8 inch. So what is 3/8 inch? Calculate 3 divided by 8. 3 divided by 8. 0.375. Yeah.
0.375.
Yeah. This should be projection. Okay, next.
An above ground storage tank contains a fluid with a specific gravity of less than 1. The thickness of the plate in the first course is 7/8 inch. What is the minimum thickness of the annular plate?
Suspect loading and first shell course. Okay, now how to answer it? If it is less than 1, we have to follow the 653 table. There is a table. See the table and answer. Thickness is 7.7/8 inch. So 7 divided by 8 will result in 0.875. 8. The table follow upon 0.875.
0.87.
So point,
So
yes, please.
0.75.
Yeah, table number, sir.
Table number, this one. 4.5 for page number 4-16. On bottom plate product specific into gravity less than 1. This table you have to follow.
How much this?
So I will display the question. Yeah. 27,850 psi. Huh?
0.31.
0.31. So how to answer 0.31? You can see it is given 0.7, 7 by 8 is 0.875. So it will come here. And the stress is given as a 27,850. So 27,850 is less than this one, 29.31.
Okay, sir. Okay, sir. Thank you.
Next one.
An above storage tank contains a fluid with a specific gravity of greater than 1. The thickness of the plate in the first course is 7 by 8. What is the minimum thickness of the under plate? System loaded and stress 27
Okay, now which table you have to refer?
per annum.
So first tell me which table you have to refer. Anybody online? Which table you have to refer? No. See, you can see here. I yesterday specifically told, I think you forget it. You can see here. For tanks in service product specificity 1 or greater, you have to refer 650 table, which require onward plates other than seismic. The thickness of the shall be in accordance 650 table 5.1A 1B. So you have to refer a 650. Just to refer it 650, I will hold this question. We will have some 15 minutes break. After 15 minutes, we will continue. 5.1B. Yeah, after 15 minutes, we will continue the class. Okay. Right. So what is the answer for this question? 9 by 32. Okay. So we have to check 650 table. Again, I am repeating. For if the specific gravity, see, a new constructed tank, to check the under bottom plate, you have to refer only 650. For in service, okay, to check the under bottom plate, there are two tables. One is given in 653, another one is in 650. If the specific gravity is less than 1, you have to follow the 653 table. If the specific gravity is 1 or greater than 1, you have to follow the 650 table. Regularly, this exam question is asked in the exam open book. But you have to keep it in mind during exam. If the specific gravity is 1 or greater, not 653 table, you have to check the 650 table. That is important. We will complete chapter 4, then we will go back to the class. Okay, yes, please, full read.
Erosion, cracking, deterioration of
Concrete.
are all examples of which of the following principles of failure or decay.
These are called deterioration of the foundation, settlement, erosion, cracking. These are foundation. You see foundation settlement, it will be there. Okay, next.
To ensure suitability for service, what is the minimum permitted frequency of tank foundation inspection?
Where it is there? Tank foundation inspection. Okay, so this is the one. The all tanks shall be inspected periodically. 4.5. They didn't specify any particular period. You can see here the principal foundation settlement erosion. That's the previous question answer. So to ensure the suitability of all foundations shall be inspected periodically. That is the answer for this. So answer is periodically. Okay, next.
Distortion of anchor bolts and excessive flashing of concrete structures may be indications of water condition.
That is the last line of this. Okay. What is that? Over seriation foundation settlement or tanker over pressure uplift condition. Where it is given here. Last one. Distortion of anchor bolts and the cracking of the concrete. Okay. Next one.
T minimum is the minimum acceptable thickness in inches for each course as calculated. What should be the minimum or value of T minimum?
Each tiny tank course. Any tank course, it cannot be less than 0.1 inch. 2.5 millimeter. Okay.
E is the original joint efficiency for the requirement thickness in a corroded plate when away from weld or joint by tank.
E is equal dash when evaluating. No. You have to read like this. E is the original joint efficiency for the tank. E is equal dash when evaluating the retirement thickness in a corroded plate when away from the wells are joining by at least the greater of 1 inch or twice the thickness, plate thickness. So E is equal to 1. Next.
What is the allowable shell product stress of the fourth course of an unknown material?
So what is the fourth course of product stress? Fourth course. Unknown material, fourth course. Fourth course stress product stress. So product stress unknown fourth course 26,000. Okay, this is the one. 26,000 because first two courses there is a separate value, third and above there is a separate value. Okay, next one. Calculate the hydrostatic. I think we calculated yesterday. Leave it. Okay, next.
What is the joint efficiency of a repeated tank but joints of 3 rows of design?
So butt joint 3 rows. Butt joint 3 rows. What is the joint efficiency for a riveted tank? So we have to see the butt joints. Yeah, 3 rows 0.85. So 0.85. So answer is 0.85. Okay, next.
During an in-service inspection of tank shell, excessive reinforcement is noted on the shell joints. Which of the following is the correct?
You remember I told excessive reinforcement, no need to grind, provided it is not inhibiting the floating roof travel. Undercut. Okay, excessive undercut, arc strike. These are no need to repair, provided they withstand the hydro test. Okay, here the reinforcement does not occur if the tank has satisfied history of service, right? The reinforcement will interfere. If the reinforcement will interfere with the floating, then it should be ground. Only A and B. Okay, so if it is interfere, we have to remove it. Next one.
Surface defect success arc strikes.
Shall be repaired, no. Shall be acceptable, no. Shall be accepted as when hydro test and will not undergo change of service. Okay. Next.
Release prevention system with respect to tank bottom.
So what is the release prevention? Internal inspection, leak detection system, cathetic, all are considered as the release prevention system. See, release prevention barrier means making a channelizing the leakage, detect a leakage and channelizing the leakage. Release prevention system means release prevention barrier, internal inspection, cathetic protection, lining, everything is considered as a release prevention system. Okay, next.
Internal inspection of the tank bottom is intended to assess
The current bottom integrity, identify problem that may lead both of them. Next,
An RBB includes
steel bottom, synthetic metal.
concrete pads and all other barriers or combination of barriers placed in the bottom of or under a tank.
Which have the function of preventing the escape of the released material. That's why I told containing or channeling the release, both of the above. Okay, calculate the minimum remaining thickness at the end of, we calculated one. Okay, no problem. Okay, next.
If the minimum bottom thicknesses at the end of the in-service period of operation are calculated to be less than the minimum acceptable bottom delivery thickness.
I told you we have three options. We can go for lining, we can go for cathodic protection, or we can reduce the insertion level, or we can repair also. The bottom shall be lined, the bottom shall be repaired or replaced, the interval of the next insertion, any of the above we can do it. Next.
What should be the acceptable minimum bottom plate thickness at next inspection for 0.06 inches reinforced bottom line tank?
Could you go back to previous question?
Yes. So any option we can go. Better we can line, repair or replace, even cathodic protection is allowed. One more is in. Is it okay?
Okay.
Right. What should be the minimum, should be the acceptable minimum bottom next to inspection 0.06 inch reinforced bottom lined tank width. So what is mean by 0.06 in reinforced means it is more than, see, we have to refer this tape. You can see here this table. Tank bottom reinforced lining greater than 0.05. What is the minimum thickness? 0.05 inch. Okay, you have to refer this one and answer. If it is greater than 0.05, so the record is 0.04. We have here 0.06, so answer is 0.05. Next.
Which of the following can occur?
That is repeat. When concrete has been exposed to sufficiently high temperature for a period of time, lot of water hydration called calcining. The basis for repair and alteration shall be equivalent to which of the following? Equivalent to APA 650. I think that's all. This is another one. This is next chapter. Okay. Right. We will go back to the code book. So we have completed review up to chapter 4. 5, 6 afternoon we will do it. Now we will go to the class. Okay. So please take next chapter. 7. Okay. So we have completed 5, 6, 7, 8 are small, 9 is the big one. So we'll just so 7, there will be no question actually. Okay, 7, okay, maybe one question only. So just we'll go through it. So highlight this one. Even though we have prepared elaborated question bank. All new material used for repair, alteration, and construction shall conform to the current applicable standard. Any new material you are using, you have to use the latest edition. That's all. Then highlight this one, 7.3. Shell plate material and the bottom plates welded to the shell shall be identified. Material identify original contract drawings, API nameplates, and other suitable documentation. Do not require further identification. If already identified, no need for further identification. Then suppose you don't know identification, we cannot identify, you have to go for a testing, chemical analysis and mechanical testing. For each individual plate for which adequate identification does not exist, shall be subject to chemical analysis and mechanical test as required by ASTM A6 or A370, including chart PV notch. Open book question. Suppose you don't know the rolling direction. See, you never remember impact. Longitudinal, there is a separate value, transverse separate value. What is meant by longitudinal? If you are cutting the specimen on the rolling direction, that is longitudinal. If you are cutting the transverse direction, that is transverse. Suppose you don't know which direction the plate is rolled, what you will do? So you have to take 2 specimens 90 degree. At least one should match the requirement. That's all. Okay, highlight this one. When a direction of rolling is not definitely known, two tension specimens shall be taken at right angles to each other from the corner of each plate, and one of those test specimens must meet the specification requirement. At least one should meet the tensile test, then it is accepted. Then 7313, open book question. For known material, all shell plates and bottom plates welded to the shell shall meet as minimum the chemistry and mechanical properties of material specified for the application with regard to thickness and design given in 650. So we have to known material, we have to follow the 650 requirements. Structural, existing rolled structural shapes that are to be reused shall ASTM A7, new structural material ASTM A36 or ASTM 9. Just to highlight it, very rarely one question asked that will be open book. The specification all don't need to remember. Then highlight this one, close book. Flange material shall meet the minimum requirements of the asphalt. Any new material, we have to use a generally current applicable. Flange, we have to use a original standard. Then roof and bottom plates. The existing or reused to reconstruct, they shall be checked to excessive corrosion and pitting. That is close book question. That's all. Chapter 6, 7. There is no question. Chapter 8, again a very small chapter. Maybe one question. What is meant by reconstruction? See, reconstruction is covered in one more chapter actually. I think 10 or 11. Now, reconstruction means we are cutting the pieces and transporting and again rewelding that, reconstructing. Now, before cutting, what you have to do, you have to completely clean the tank and completely gas free, remove the gas, everything. And we have to take thickness measurement of each shell core. The thickness measurement, once you have taken, it is valid for only 180 days. 180 days, na 6 months. Suppose if you are not able to reconstruct tank within 6 months, again we have to take reading because it will corrode. That is the only point important. Highlight this one. Any specific design condition other than normal product loading shall be specified by the owner operator. Reconstruction, if you are using other than normal product, owner operator shall be specified. Then highlight this one. Weld joint detail whereas current applicable standard, close book question. Then this is what I said. This is important. Thickness to be used for each shell course when checking tank design shall be based on the measurements taken within 180 days prior to relocation. So you have to take within prior to 180 days. Then which code you have to use allowable stress? Highlight this third line. The allowable stress of the material shall be requirement 655.2b. For material not listed in 5.2b, the allowable stress is 2/3 of yield strength or 2/5 of tensile strength shall be used. We have to follow the 650 requirement. Reconstruction, we will follow the 650 requirements. Then how we will decide what is the liquid level we can fill? Because it is not a new tank. When you have a reconstruction, suppose I have 6 shell courses. It is not mandatory. Each shell course is corroded uniformly. Some shell course may be corroded more, some shell course may be corroded less also. So what you have to do, we have to check the thickness of each shell course and we have to calculate the design liquid level for each shell course. And whichever resulting in the lowest level, that should be the tank fill level. புரியுதா? ஒவ்வொரு ஷெல் கோர்ஸும் கொரஷன் வித்தியாசமா இருக்கும். ஏன்னா we are going to construct same order only, we are going to construct it. So if each shell course is differently corroded, we have to measure the thickness and calculate the design liquid level using the formula, H formula. But so each one will have a different values. Which is the lowest value, it will be considered as a tank fill height. Okay. The maximum liquid level for hydrostatic shall be determined by using the actual thickness measured for each shell course, the allowable stress for material of each shell course and design method. The allowable stress for material shall be determined 650. For material not listed, 3/4 of yield strength or 3/7 of tensile strength shall be used. These all are 650 requirements you have to follow. Reconstructed tank. Suppose if you want to give corrosion allowance, you have to reduce the corrosion allowance from the plate. If a corrosion allowance is required for the reconstructed, the required corrosion allowance shall be deducted from the actual thickness before calculating the maximum liquid level. Then the joint efficiency and allowable stress used for the design calculation shall be consistent with the design method. The joint efficiency allowable stress existing are not to be removed and replaced shall be based on the original degree. Suppose you are not removing a joint. All joints they will not remove. The next chapter we will see how to cut a tank. No need to cut all joints. If you are transporting a long trailer, you can make 2-3 shells together, cut it and send it for that same joint you can use it. When you are using a old joint, the efficiency, everything you have to take, which is followed in the original penetration. Shell penetration, just to highlight, replacement and new penetration shall be designed, detailed, welded, and examined current applicable standard. Existing penetration shall be evaluated as built to standard. So if you are, say, simple logic, where you use a current applicable standard, current applicable and the latest code. If you want to do anything new, current applicable. If you want to use the original one, as built to standard. Then last one, suppose your tank was previously in a location where there is no seismic problem, seismic and other earthquake problem, but the new location have earthquake problems, then you have to put a bottom, you should put a anchor bolt. Okay. Reconstruct tank shall be built to meet the stability requirements of the current applicable standard. Thickened bottom plates under the bottom shell cores or anchoring of the tank may be required, even if not used on the original tank. That is open book question. Now, this small chapters, generally they will ask one question each, but sometimes you find it tough. That's why I'm telling, attend the question. We will try to attend the questions because we marked line by line question. Okay. Next, we will go to the chapter 8. Tank repair and alteration. I can say the most important chapter of the 653. It will have around 20 questions. Yeah, it will have around 20 questions, at least 15 questions. But it is not as tough as chapter 4. There is no calculation. Okay. So this is talk about the repair and alteration. So what we are going to discuss first, we are going to check about the how to repair a shell. Then we will discuss how to repair a bottom. Okay, and we will go to the roof repair also. So first, who will authorize the repair? If it is only repair, it will be inspector. Alteration means inspector and the engineer. Alteration involves a design. Inspection hold points, you will designate inspector. Any small repair, inspector can have general authorization. Regular small little repairs. Then if you take the shell, there are two types of repair. One is called the flush patch, another one is called the fillet patch. Flush patch means we will cut and remove the plate and will with a full penetration weld. Cut and remove the plate and put a new plate. That is called a flush patch. Fillet patch means already plate is there. Above that we will put a fillet weld. So shell, because shell generally butt joints. So in shell repair, flush patch is also allowed, fillet patch is also allowed. Both are considered permanent repairs. If you go to the bottom, generally they will go only for fillet patch because bottom are lap wells. No need for the flush patch. So what is important for exam? Each one there are many requirements are given. When you are preparing for the 653 exam, read chapter 4 and chapter 9 very carefully. Chapter 9 will have a lot of questions. Okay, let us start slowly. Highlight the first one. The basis for repairs and alteration shall be 650 equivalents. Close book question. Then 913 first line. All repair work must be authorized by the authorized inspector or engineer experienced storage. That is general statement. Generally, any repair inspector or engineer. Next line you can see, next line, authorization for alteration that completely may not be given prior consultation and approval engineer. So alteration engineer approval is a mandate. So I will put it like this. Repair inspector or engineer, alteration inspector and engineer. Alteration both has to authorize it. And engineer. Repair anyone can authorize. Then third line, the authorized inspector will designate the inspection hold point requiring the during repair and alteration sequence of minimum documentation. The authorized inspector may give prior general authorization for limited or routine repairs as long as authorized inspector is sure that the repair will not require the hydrostatic test. The 914, all proposed design, work execution, materials, welding procedure, examination must be approved by inspector or engineer. That line is also important. All procedure, who will approve the procedures? Inspector or engineer. Now we will go one by one. Now, replacement plate. So first we are going for the shell replacements. We are cutting to replace plate. First one, what is the shell replacement? So first condition, what is the minimum size of the replacement plate? Minimum size is greater of 12" or 12 times thickness. T is the shell plate thickness, actual thickness. So 12" or 12 times. So any replacement plate should be at least 12". You cannot cut a replace or 12" or 1 foot. Less than 1 foot you cannot cut. The next question, what is the maximum size of the replacement plate? Maximum, there is no limit. You can, if you want to replace any shell, number of shells also we can replace. So maximum, no limit. Maximum, no limit. Second point. I will just put points so that you can easily understand by reading. Third point is, okay, what should be the, see, this is your shell. And if you want to replace a plate, very important is what should be the corner of the plate. The corner, you should have rounded corners. Always should have a rounded corners. What should be the radius? 6" or 60, whichever is greater. So corner radius (6" or 60, whichever is greater. Okay, this point you have to remember. Now, what is the next point? Suppose, no, first understand this, then you can no need to write. Just you want to make a replacement fit along with a horizontal weld. This is the horizontal weld. So what the code says, you have to cut the horizontal weld like this. How much area cut? From the joint 12" this side, 12" this side. Then how we will do the welding? First weld this area, all are butt weld. Then finally we will weld this area. So when you are any replacement coming along the horizontal joint, then you have to cut the horizontal existing weld 12" more than the size of the plate, both sides 12". So first all other welds you have to complete, finally horizontal joint we will weld. Next one. Is it clear? These are open book only. Another one is, if you are making a joint with the shell to bottom. Suppose you are making a shell to bottom weld, a replacement plate. Now, very important is this should have a tombstone shape. So, what is meant by tombstone? This one, this shape. This should have a tombstone shape. The first condition. Another one more condition is, if there is a bottom, what will be the bottom plate? Will have an annular plate. Any annular plate butt joint is coming like this. Butt joint will not annular plate. Butt joint should be, the distance between annular should be 3" or 5T, whichever is greater. Definitely, whatever I said, there will be at least one question will be there. Again, I will repeat. Shell replacement plate, definitely there will be one question. The first one is the closed book question. All other I said are open book questions. So what are the key points you should know? I told you what is the minimum size? Greater of 12 inch or 12 feet. Minimum. Maximum, they have no limit. The next one, when you are welding any replacement with horizontal, we have to cut the horizontal both side 12 inch, then we have to weld it last. And if anything, if we are making the bottom core shell with the shell to bottom, it should be tombstone shape. And the distance to any annular plate weld, annular plate will have a weld minimum 3 inch or 5T, whichever is greater distance you have to shift it. These are the key points. There are other things are there. So we will go to the code book now. Highlight this one. Minimum thickness of replacement shell plate, removal and replacement. Second line, the thickness of the replacement shell plate shall not be less than the greatest nominal thickness of any plate in the same course adjoining the except that the adjoining plates. Generally, what thickness you have to use? The adjoining course plate. Same plate thickness you have to use it. Which course you are replacing? Then this is a closed book question. The minimum dimension for a replaced plate is 12 inch or 12 times thickness, whichever is greater. Very, very important. Closed book question. Minimum dimension of replacement plate is 12 inch or 12 times thickness, whichever is greater. Then next one. The replacement plate may be circular, oblong, square with rounded corners or rectangular with rounded corners, except when the entire shell is replaced. That is closed book question. Suppose you are cutting the entire shell. No need to round it because it will have a longitudinal and vertical. Then the last line is a open book question. Prior to welding the new vertical joint, the existing horizontal shall be cut minimum distance 12 inch beyond the new vertical. The vertical joint shall be welded prior to welding the horizontal joint. So 12 inch we have to cut it. First you have to complete the vertical joint. Finally, we have to weld the horizontal joint. I explained everything. I hope you understand. That is open book question. Then next page, you can see the sketch. See now by this is a replacement. You can see the heading here. Acceptable details of replacement shell. Now what is A? What is the A? Minimum dimension of the replacement. You can see A. So what is A given here? You can see 12 inch or 12T. A is the 12 inch or 12T. Now what is the B? If you are making a plate from the bottom, what should be the minimum distance between the bottom and the plate? So B, what is the B given here? When the thickness is less than half an inch, 6 inch, more than half an inch, 10 inch or 80. So there will be definitely a open book question. You should understand what is A, B, C first. Just to see the table and answer is. So there are two tables. When the thickness is less than or equal to 0.5, thickness greater than 0.5. So B is now what is the B? From the bottom plate dimension, shell to bottom welded dimension. What is C?
B என்ன சார்? B எங்க சார் இருக்கு? B என்ன சார் சொன்னீங்க?
இங்க இருக்கு பாருங்க, இங்க இருக்கு பாருங்க. B.
Okay சார், அது என்ன சார் அது?
So if you are making a shell plate replacement in the first shell course, what should be the minimum distance from the bottom shell to bottom weld?
Okay sir.
Third one is if you are making with the shell to bottom weld, what should be the distance between the annular plate weld? The dot is the annular plate. So what is the annular plate? Greater of 3 inch or 5T. Very, very important. Okay, that is C. What is D? D, there is no D. Okay. Then what is R? R is the radius. So what is R? 6 inch or 60. So less than half an inch or 6 inch, greater half an inch, 6 inch or 60, whichever is greater. Then what is the H? H on the distance from the horizontal weld. What is the H? When the 3 inch, then greater of 10 inch or 8. B already seen, vertical, A already we have seen. This table is very, very important. Last exam, there was a question. During a replacement shell plate, a tombstone was used with the shell to bottom. The answer, the question they asked, why the tombstone was rejected? The reason is, it is not 3 inch 5T. It doesn't meet the requirement from the annular plate. It is very close to the annular plate, so it was rejected by the inspector. Just I mark it, remember this one. Why tombstone is rejected? This was asked to the last question, last exam. So we have to see this table, this condition. So R means radius. When the thick, again I will repeat, then the thickness is less than half an inch, there should be minimum 6 inch. More than half an inch, 6 inch or 60, whichever is greater. B is from the bottom weld, less than half an inch is 6 inch, more than half an inch 10 inch or 80, whichever is greater. Horizontal weld, minimum 3 inch when the thickness is half an inch, less than half an inch and more, 10 inch or 80, whichever is greater. Vertical 6 inch and greater of 10 inch or 80. A dimension, what is A? Then size of the plate. Replacement plate, greater of 12 inch or 20. C means what is this distance from the annular plate weld to the bottom weld. That is one. That is a vertical weld of this one. This is 3 inch or 5. Definitely there will be 1 or 2 question will be asked from this. So please online, if you have any doubts, unmute yourself and ask question. I will answer. Yes, please. Which one? No, there was a question asked. They told during the question was framed like that. During a bottom shell core replacement, a tombstone was replaced and the tombstone was rejected by inspector. What is the reason for rejection? The answer was actually for that question, the vertical weld of the tombstone is less than 3 inch from the annular plate butt weld. That's why it is rejected. Yes, C dimension was less. That's why they rejected it. That was there was a question, some feedback. Student give feedback. Yeah, it should be shift to this side. You can see here, this is the vertical weld.
Yes.
This side they shift to 3 inch. This side they bring back inside 3 inch. Either both side it can be, either inside or this one. You can see the dot. This is the 5 times thickness of the shell. Shell. T is always shell. T is the shell course only. Okay. B எல்லாமே ஒண்ணுதான். எது எங்க அந்த கர்வ் ஸ்டார்ட் ஆகணும், ரேடியஸ் இந்த பாருங்க, இங்க வந்து B is from the where the plate starts because it is a circular shape. When you have a tombstone shape, what should be the minimum B dimension when the curve start? Tombstone ஒரு half round ஸ்டார்ட் பண்றாங்கல்ல, அது வந்து உள்ள டிஸ்டன்ஸ்ல ஸ்டார்ட் பண்ணும். Then highlight this one. Shell replacement shall be welded with the butt joint with the complete penetration and complete fusion except permitted for the lap patch for repairs. Now this one 9233, all the table only. The table only it is given in the paragraph. If you understand this, see what is VRB, VHC, VAC. This is the explanation they give the in here. You can see here, for existing shell plate over half an inch thick, the outer edge of butt welded attaching the replacement shell plate shall be greater of 8 times the weld thickness or 10 times outer edge of any existing butt weld. So this is 8 times weld thickness or 10 inch. That is here. Any butt welds greater of 80 or 10 inch from which one 8 inch, 10 inch, all this horizontal, vertical, any butt weld 10 inch or 80. This is the same only. If you understand this one, no need to this. Then highlight this one. For existing half an inch thick or less, the spacing may be reduced 6 inch from the outer vertical and 3 inch from the horizontal. From same sketch only. See, vertical 6 inch, horizontal 3 inch. When the thickness is less than half an inch. The explanation is given here. And this is open book question. Yeah. Either you can read the explanation and answer it, or you can see the sketch and answer. Yeah. Yeah, table explanation in this paragraph. For shell plates of unknown toughness not meeting the exemption, the edge of any vertical joint replacing plate is thus 3 inch or 5 T edge of the welded joint in the bottom annular ring or welded joints in the bottom plate. That is open book question. 3 inch or 5 T from the bottom plate weld. Now we will go to the door sheet installation. Okay. Is it okay? Definitely there will be 2 questions at least from the replacement shell. Now next one will say how to put a patch plate on the shell. So door sheet, after that will go. So highlight this one. The door sheet installation shall meet requirements. This are another. Highlight the 9224. For lap welded and riveted tanks, reinstallation of the original plate section that cross an existing horizontal seam is not permitted. That line is important. You cannot put a lap welded and original plate. You cannot put a door sheet on the existing one. Then this, you can see the drawing, detailed of source shields in the riveted seam. So it was asked in one of the exam open book. So answer is you have to from 4. Rivets at the existing lap rivet seams located within 12 inch of a weld may need to be sealed or caulked or seal better to prevent product seepage. That is important. Highlight the 4. If you are putting a door sheet near on the riveted cell, then highlight the 5. Prior to welding any vertical seam, intersect the bottom, cut the existing the shell to bottom for a minimum of 12 inch. We have to cut it. And the cut shell extend past 3 inch or 5 T from the shell to bottom weld. Then next one, details of door sheet for lap welded seam tank. Same, highlight this 4. Same only. Prior to welding vertical joint, shell to bottom minimum 12 inch. That condition. It was rarely asked in open book.
Sir, these are the conditions same mentioned in table number 9.1 as well, right? Is that right, sir?
Yes, same, almost same.
But it's
Yeah.
actually repeating again and again.
Again, because it is a door sheet, they are talking about the door sheet. Same condition only. Yeah,
Even
but
the-
welded. Yeah, the condition is same, but because of the door sheet, they are again they are writing here. Prior to
but
welding.
if you are thorough in one concept, we can
Yeah,
use
we can attend. Yeah, you can easily attend. all the-
and we can even for these questions we can look on the tape, because once we know the condition is same in the exam, they're going to ask in the open book, right, sir? Is it
Yeah,
going to
it
be
will
in
be
the open book?
open book only. These questions will be open book. If you understand the table properly, then no need to read the paragraph. By seeing the drawing, you can answer all the questions. Okay, this one is open book question. The same only. New weld seams in riveted tank shall be located minimum 12 inch from the existing rivet seams to minimize the potential for seams. So if you are welding on the riveted, it should be 12 inch from the rivet. 9249 open book question. Now we will go to the lap patch welder repairs. Very, very important. Again, there will be at least 2-3 questions on the lap patch welder. At least 3 questions. Now, what are the key points? Butt weld, what is the minimum dimension? Flush patch repair. Flush patch na butt weld. Minimum, what is the dimension I told? 12 inch or 12T, whichever is greater. Lap weld minimum dimension is 4 inch. Any lap patch plate, you are putting a plate to patch plate, what should be the minimum dimension? 4 inch. What is the maximum dimension of butt welded? Unlimited. I told you there is no limit. Any cell course you can replace. Fillet weld patch maximum limit is vertical 48 inch, horizontal 72 inch. 4 feet to 5, 6 feet. That is the maximum patch plate you can use it on the cell. Is it clear? Third condition, what is the corner radius you told for 6 inch or 60? Here it is 2 inch radius fixed. Patch plate on the 2 inch. I just comparing so that you can easily keep it in your mind. Okay, 2 inch radius should be there. Now, what are the other important points?
Sir?
Yeah. Yes, please. No, there was some disturbance. I mute it. Yeah.
Sir, nothing. So if you can give me like a usually in a 510 you put as a table column, right? So when it's going to be comparison.
It is because it is a very lot of points. We cannot make a table.
Okay, sir.
Okay. This is not 1 or 2 points, many points. So just I will tell. Again, I will compare. For butt welded patch, minimum. We are talking about the shell. Don't confuse with the bottom plate. Bottom entirely different. If you tank anywhere, shell conditions are different, bottom conditions are different. Shell, we have 2 types of repair. One is called flush patch. Flush patch na butt welded. Another one is called fillet patch. Fillet weld patch na patch plate over the existing plate. Butt weld minimum dimension. What is the minimum dimension? I told you 12 inch or 12T, whichever is greater. Fillet weld minimum dimension is 4 inch. Butt weld maximum, there is no limit. Fillet weld maximum is 48 inch vertical, 72 inch horizontal. Butt weld, what is the radius? I told you 6 inch or 60, whichever is greater. Fillet weld maximum 2 inch. This is just we can compare it. But there are other conditions for fillet weld. Any shell thickness greater than half an inch, fillet weld patches are not allowed. If the shell thickness is more than 12.5 mm, half an inch, fillet weld patch is not allowed. Next one, when you are making a fillet weld patch, you should scan the area first to ultrasonically check for lamination, and you have to attach a fillet weld patch. Okay. And what should be the minimum size of the fillet weld patch? Minimum 5 mm. Any fillet weld patch plate you are using 5 mm, minimum 5 mm thickness. Maximum thickness is half an inch. Maximum more than half an inch you cannot do. Okay, these are the important, but there are other conditions. So highlight this one. Lap repair, shell repairs are an acceptable form of repair on butt welded, lap welded, and riveted tank shells under the condition of 932 to 934 only when specified by the owner operator. When owner operator says only fillet weld patch are allowed. Otherwise, shell we have to go for butt weld. The next line, these repairs are permanent repairs. See, in pressure vessel and piping, fillet weld patch never considered as a permanent. They are temporary. But a tank fillet weld patch are permanent repair. Subject to the ongoing inspection and maintenance program, these requirements may be used to evaluate the existing lab. However, the plate thickness limit need not apply. So first one point. All repair materials shall comply with the requirements of current applicable standard. Highlight this one. Second one is the closed book question. Lapped patch repair shall not be used on any shell core thickness, original construction that exceeds half an inch, not to replace a sheets, door sheets or self. The original thickness is more than half an inch, patch plates are not allowed. Condition number important, close book. Except as permitted, the repair plate material shall be the smaller of half of the thickness of the shell plate, but not less than 3 by 16 inch. Very important. So it cannot be less than 3 by 16 of 5 mm plate. The 9314 important. The shape of the repair plate may be circular, oblong, square, rectangular. All corners except to the shell to bottom shall be rounded minimum 2 inch radius. That is a closed book question. Fillet weld na 2 inch, butt weld na 6 inch. Then if you are crossing the seam, for example, horizontal or vertical weld, you are putting a patch plate, minimum 6 inch you have to cross. Again, it is a open book. The repair plate may cross any butt welded vertical or horizontal cell seam that have ground flush, but must overlap 6 inch beyond the cell seam. That is important. So when you are crossing a butt weld, what you have to do? First, you have to flush grind the butt weld in that location. Then you have to do MPI. Then we have to attach the plate and weld it. Then this is another important. The maximum vertical and horizontal dimension is 48 and 72. The minimum dimension is 4 inch. Then you cannot put a shell opening nozzle on the patch plate. Shell openings under the reinforcement shall not be positioned within a lap patched shell repair. That is closed book question. Then 9319. Prior to application of lapped patch, the areas to be welded shall be ultrasonically examined for plate defects under remaining thickness. Then 10th last point. Repair plate shall not be lapped on a lapped weld seams, riveted seams, all this. That is not important. So total 10 points. So what are the key points I told? What is the minimum dimension? 4 inch. Maximum 48 vertical, 72 horizontal. That is important point. When patch plates are not allowed, when the thickness is more than original thickness is more than half an inch, not allowed. Second one, what is the radius? Minimum 2 inch radius. Okay. Then what is the other point? And the if it cross any vertical or horizontal seams, minimum 6 inch it has to cross. Okay. Why? What is the minimum plate thickness? 3 by 16 inch. These are the, yeah, 5 mm. Maximum on the half of the thickness. Yeah. Yeah. Less than half an inch only allowed. Is it clear? Definitely 2-3 questions will be there. Now, what are the other areas we can use a lapped patch? Suppose you remove the nozzle in a shell. See, this is a shell. There is a nozzle here. You cut and remove the nozzle. Then it can be covered with a lap patch plate. You can put a patch plate, cover the hole. There is a hole actually. Cover the hole. So patch plate will be welded like this outside. And you can go inside and weld this one. Inside we have to go inside weld the hole. With our hole, we will put a patch plate outside. Outside a patch plate completely we will weld it. Inside on the hole is there. Hole we will weld it. If hole we have to weld a fillet weld around the hole. For this, நாசில ரிமூவ் பண்ணிட்டீங்க. ரிமூவ் பண்ணிட்டு அந்த இடத்துல ஹோல் இருக்கு டேங்க்ல. ஹோலுக்கு ஹோலை அடைக்கணும்னா என்ன பண்ணா ஒரு பேட்ச் பிளேட் போட்டு அடைக்கணும். பேட்ச் பிளேட் போட்டு அடைச்சிங்கன்னு வச்சுங்க, உள்ளார போய் அந்த ஹோலை வந்து அந்த பேட்ச் பிளேட் ஹோல் டு பேட்ச் பிளேட் ஃபில்லட் வெல்டு அடிக்கணும். அவுட் சைட்ல ஃபில்லட் வெல்டு ஃபுல்லா அடிக்கணும். ஓகே. Now what is the condition for this? What should be this patch plate dimension? So what is the hole dimension? For example, hole dimension say 8 inch. So if this side 1 inch, this side 1 inch. So what should be the minimum dimension? 10 inch. Hole plate order in the side at least 1 inch, minimum 1 inch overlap. Plate should be overlap. There is another condition. Suppose a hole is only half an inch size. Half an inch very difficult to weld inside. So what the code says, suppose you are removing a half an inch nozzle. It is very difficult. So we have to make a hole bigger for welding purpose. So what should be the minimum hole dimension should be 2 inch. So what is the size, the minimum weld size will be 4 inch. Again, I will repeat. Patch plates can be used to fill a hole because of the nozzle removal. The minimum size of the hole should be 2 inch. Suppose actual nozzle removal is say 1 inch, we have to make a hole bigger, 2 inch. Minimum size of the plate will be 4 inch. 4 inch na 2 inch, 1 plus 1. Okay, so see, it will be welded. What is the joint efficiency? There is one more thing. Remember in the patch plate welding, when welding on both sides, so it is a fillet welding. Fillet weld on both sides. E we will take 0.7. Fillet weld one side only. We will take 0.35. Now what efficiency we will take for this? 0.7, because we are welding here. You can see here welding. We are welding the patch plate here outside, and we are going inside the tank and welding in the hole area also. So double side welding, you have to take efficiency 0.7. Sometimes the previous one I told general patch we are welding only one side, then efficiency will be 0.35. Double side welding na 0.7. Another important is any patch plate. What is the minimum thickness of the patch plate? Just I told 5 mm, 3 by 16 inch. 3 by 16 na 5 mm, 4.8 mm, 5 mm. Any patch plate na thickness tha. So please take. These are not very important. Highlight this one. Lapped patch repair plates may be used to the closure holes caused by removal of existing shell openings. In addition, the following requirements shall be satisfied.
Sir, அந்த 3.5 என்ன சார் சொன்னீங்க அது?
3.5
நீங்க எக்ஸ்பிளைன் பண்ணீங்களா சார்?
3.5 உள்ள 0.35.
0.35 அது என்ன சார் சொன்னீங்க அது? One side.
When you are welding patch plate, suppose you are putting a patch plate and welding only outside.
Okay.
The efficiency will be 0.35.
அந்த மாதிரி பண்ணலாமா சார்?
ஆமாமா. Yeah, generally if there is no hole, how we will go and inside weld? Only one side we will weld a patch plate.
Okay sir.
Because there is a hole,
okay,
we are welding on both sides, then it will be taken as a 0.7. Double side welding.
இது வந்து நீங்க சொல்றது வந்து பாத்தீங்கன்னா லைக் ரிப்பேர் வேற ஹோல் இல்ல நாசில் இல்லனா பேட்ச் பிளேட் மட்டும் போடுறதா அந்த மாதிரி சொல்றீங்க.
ஆமா 0.35 தான் efficiency.
Okay.
Hole repairல வந்து it will take it as a 0.7 because we are welding on both sides.
Okay sir. Instead of welding on both sides, we can't fill it with the filler material, sir.
No, it is not allowed.
Okay.
Okay. Then please go to the 9321. The welding shall be continuous on the outer periphery of the repair plate and the inner perimeter of the shell plate, inner perimeter of the hole in the shell plate. The minimum hole diameter is 2 inch. Shell opening due to plate removal shall have a minimum corner radius. See, always fillet weld 2 inch. It will repeat many times. Any fillet weld corner radius 2 inch. Any butt weld, what is the corner radius? 6 inch. Remember this. That was the 66 inch minimum. The repair plate thickness selection shall be based on the design that conforms to the ASBIL standard using a joint efficiency not exceeding 0.7 because we are welding both sides 0.7. The welds of the repair plate shall be full fillet. The minimum repair dimension shall be 4 inch and the minimum overlap 1 inch. Maximum overlap 8 times of the shell thickness. What should be the maximum overlap? 8 times of the shell thickness. Very important open book question. Minimum வந்து என்ன சொன்னேன் 2 inch ஹோல்னா 4 inch plate 1 inch overlap. 1 inch overlap minimum. Minimum வந்து total overlap எவ்வளவு? 1 inch one side. Maximum 8 times thickness. But suppose thickness is say 5 mm. Minimum thickness we are using 5 mm. 8 times 5 னா எவ்வளவு overlap வரும்? 40 mm. 40 mm means it will be 1.5 inch. More than 1.5 inch overlap. Okay. That is the first one. Now next one is that is 932. See, we are first we have seen 931. 932 is the how to repair a hole. 932 is a hole. 933 is a lapped page used to refer severely deteriorated that are not resistant to service loads. Suppose severely corroded area. You can use, see, first 10 condition we have seen, it's a general. We are going to one by one now. How to repair a hole, how to repair a severely corroded area, how to repair a crack. So these are same repeat. Suppose severely corroded area, what we will do? We will put a patch plate. What joint efficiency? 0.35, because only one side we are welding. What should be the minimum thickness? 3/16 inch. Same will repeat. Okay, highlight this one. Lapped patch repair may be reinforced severely deteriorated shell plates that are not able to resist. The 9331 open book question. The selection of the repair plate thickness shall be based on a design that conforms the ASBIL standard using a joint efficiency not exceeding 0.35, because only one side welding. That is the logic. See, whenever you want interpretation of the code, you have to understand how it is written, what intent it is written. Then the repair plate thickness shall not be exceed the shell plate thickness of perimeter by more than 1 part, not more than 1 by. The repair plate thickness shall not exceed half an inch. Maximum is half an inch. This is open book question. Minimum thickness will be 3/16 inch. Then 934. Lapped patch repairs may be used to small leaks to minimize small leaks. Also, we can use a lap patch. Same it will repair. 934 to repair descent to stand efficiency 0.35. Again, repair thickness shall not exceed the parent by more than 1/3 mm. The repair plate shall be not thinner than 3 by, not thicker than half an inch. Any lapped patch repair, please remember maximum thickness allowed is half an inch. Minimum thickness allowed is 3/16, 5 mm. What is the actual thickness should be? The actual thickness of the plate. Shell plate, we have to use it. It cannot be more than actual plate by 3 mm. Suppose actual plate is say 5 mm. You can maximum use 8 mm plate. You cannot use more than 8 mm plate. Okay. Then this repair method shall not be used if exposure of the fillet weld to produce crevice corrosion or if the corrosion cell, this one, just to highlight it. Okay, a short break or 5 minutes break. After break, we'll continue.
Sir, 8 mm என்ன சார் சொன்னீங்க?
It shall not exceed the shell. See, the repair plate shall not exceed the shell plate thickness by more than 1/3. Okay, but no more than 1/8 inch. The repair plate shall not exceed shell plate thickness. கூட எவ்வளவு போக கூடாதுன்னா 1/3 thickness கூட கூடாது. But forget about the 1/3, not more than 1/8 inch. 1/8 inch na 3 mm. Suppose your shell plate thickness is say 8 mm. The maximum thickness you can use patch repair is 11 mm. Ama. But the minimum thickness on the, but it cannot more than half an inch. It cannot more than 12 mm. You cannot use. Minimum thickness always 5 mm.
Okay, sir.
Right.
Okay, sir. Okay, sir. Thank you.
For 5 minutes break. After break, we'll continue.
Okay, sir.
Recording. Yeah. Okay, good. Now we will go to the next one. Repairing using non-metallic materials. Okay. So it is allowed by the code. Generally, non-metallic soft patches are allowed in roof repair actually. It is not considered as a permanent repair for shell and bottom, non-metallic repairs. Non-metallic can be made on shell plate or nozzle neck to restore the hoop strength capacity lost due to corrosion. The owner operator, storage engineer, and the composite manufacturer shall evaluate the ability of the non-metallic repair to restore the hoop strength and consider the possibility of non-tensile related forces damaging the composite. The tank shall be assessed to confirm it is sufficient to handle tensile, external, and seismic loads. When you are using a composites without welding, non-welded repairs or non-metallic, the engineer should evaluate it. Just to highlight this, not very important. Then repair to defect in shell plate. The need for repairing indications such as cracks, gouges, or tears Widely scattered pits during inspection shall be determined on the individual. Just to highlight it. Then the last line is important. If more extensive area shell plate require repair, use the butt welded shell replacement plate and lap welded plate shall be considered. That is important. Suppose you have many cracks in a shell plate, or you have a severely corroded lot of area. Instead of repairing each and every area, better to replace or put a full patch. Okay, this is important. This was asked in the some during inspection. Inspector noted there are many cracks in a shell plate. Which of the following is a corrective action? Replace the plate. Then alteration to tank shells or changes shell height. Tank shall be altered by, see, I told you any tank shell alteration is considered as a alteration. Increase the height of the tank. The modified shell height shall be upon the requirements of the current applicable standard. I take into consideration wind and seismic load. That is close the question. That's all. We have completed the shell repair. Now we will go to the shell weld repair, not a shell repair. Weld repair, na any defective weld. Okay. This is all shell only. Still, we are going shell only. Repairs on shell weld flaws and defects. We are talking about the weld defects. Weld defects, what we will do? We will grind and repair it. So wherever repair we done, we have to confirm with the radiography. That's all same simple only. Cracks, lack of vision that need to repair shall be complete. Excessive reinforcement shall be repaired by grinding. Unacceptable shall be repaired. So highlight the 974. Welder joint, the expense unacceptable loss due to corrosion shall be repaired by grinding and welding. Then highlight this one, except that repairs for undercut, corrosion and surface defects in butt welds do not require radiography or transecting. Now we will go to the repair to shell penetration. Yes.
Shell weld has been cut and rewelded. Then they're supposed to have any hydrosis or not.
See, if you are welding a shell repair more than 12 inch, it is considered as a major repair. Major repairs require hydro test, but there is exemption is allowed. Only reconstruction, no exemption. Hydro test is mandate. If you are going for alteration, there is no exemption. But major repair, it can be exempted, provided engineer accept it, and we can go for. There are a lot of requirements are there, but not mandate. Hydro test is not mandatory for major repairs. Okay. Repair to shell penetration. So repairs to existing shell penetration, AP 650 we have to follow. Reinforcing might be ordered to the existing unraised nozzle when deemed appropriate. Suppose there is no reinforcement, you want to reinforcement, you can add it. Then what should be the weld size when you're adding reinforcement? You can see fillet weld A. What is the A fillet weld? It is between the nozzle and the reinforcing plate. This table is open to question. What should be the minimum fillet size based on the T and the T? What is small t? Small t is the shell thickness, capital T is the reinforcing plate thickness. That is open to question. The next page, suppose you are adding with the shell to bottom weld. This shape is called a tombstone. Then what should be the B dimension? P is the shell to bottom weld reinforcement. Directly we are attaching shell to bottom weld. What should be the B dimension? Also open book. Now, here there is a problem. So, any reinforcing plate will have a holes. What is these holes are called? Telltale hole or weep hole. What should be the distance telltale hole from the horizontal joint? 2 inch or 60. And what should be the hole size? 1/4 inch plus 1/8 inch thread. Now, suppose, understand this sketch. You have a shell. And this is a shell to bottom. We have a weld like this, fillet weld. Now you want to attach a reinforcement plate from here. How we will attach a reinforcement in this location? Now we have to weld it here like this. So we have two options. One option is we have to make a groove cut on the plate. So plate will be like this. Plate will be installed like this, so that this weld will be left. Another option is you have to grind the weld and make the plate straight. If you want a full plate, then we have to remove the weld. எப்படி இல்லாட்டி பிளேட் போய் சீட் ஆகாதல வெல்ட் இல்லை. ஸோ டு சீட் த வெல்ட் எய்தர் we have to trim the plate or we have to trim the weld. Both options. So it is this sketch is this one only. You can see here sketch. The previous page, I think. So this is the sketch they have given. Lapped patch at external shell to bottom joint. You have to cut this page number 9-7 la கொடுத்திருக்காங்க. Either you can cut the plate or you can make this one like this. But that is not important. Then next one, 983. Suppose to avoid this type of problem, you can order reinforcement plate inside also, shell, provided the nozzle have extension inside. Suppose nozzle have inside extension, reinforcement plate may be provided inside also. So highlight this one. As an alternative, the reinforcement may be added to the inside of the tank provided sufficient nozzle projection exists. That is closed loop question. Then adding or replacement of shell penetration. New shell penetration shall be in accordance with the material design as per 650. That is important. Suppose you want to add a new nozzle, you have to follow 650 rules. Then this is tapering. Tapering everywhere it is common. What is the tapering? 1:4. Highlight this one. All integral part thickened should be 1:4 reduction. Last line. Close book question.
இங்க 1:4 சார். வேற எங்கேயோ இடத்துல 4:1 பார்த்தோம் சார்.
Both are same. Both are same.
சார் அப்போ क्वेश्चनல 1:4 and 4:1
And they will not give. அந்த மாதிரிலாம் கொடுக்க மாட்டாங்க. They will not give like this.
Okay.
Okay. Next. Now 996. This is important. Penetration larger than NPS 4 shall be installed with the use of an insert plate or thickened in very important. If the shell plate thickness is greater than half an inch. Suppose your shell plate thickness is greater than half an inch, and if you are installing a new nozzle greater than NPS 4, you have to use a insert plate. Insert plate separately, you have to weld it, then you have to replace. Okay. And does not meet the current design. The addition for following requirements shall be met. First one is open book. Second, for a circular insert or thickened insert, the minimum diameter shall be at least twice the diameter of the opening in the insert plate, accommodate the radial, or the diameter of the opening plus 12 inch. Now, what is the meaning? Suppose you want to install a new nozzle. Okay. We want to make a insert plate welded here. Insert plate means we will make a prefabricate a nozzle with the plate, then we will weld it here. Okay. What should be the dimension of this plate? What should be the insert plate dimension? So, suppose I have a nozzle dimension is say 88 inch. Nozzle is NPS 8. So what is the dimension of the plate? Read this and answer this. Read the second paragraph and answer. Suppose you have a NPS 8 nozzle. What should be the insert plate minimum dimension? Okay, now what is the answer? What is the twice the diameter? 2 into 8, 16, or 8 plus 12, 20, whichever is greater. We have to use a minimum 20 inch. Okay, we have to, this is regularly asked for exam question. When you are adding a insert plate, what should be the insert plate dimension? If a circular C greater of twice the diameter of the opening, or the diameter of the opening plus 12 inch. Very, very important. And when the insert plate is mandatory, when the nozzle is larger than NPS 4 and the shell plate thickness is more than half an inch. Now, what is meant by new bottom? I told you, when the bottom is severely corroded, there is no choice of repair. Repair means only small area we can entirely repair. So they will go for a replacement of the shell bottom. How they will replace the shell bottom? See, this is my bottom like this. Then what they will do? They will completely clean the tank and the gas free it. Then they will fill with the what pad you want, concrete or soil. Then they will cut the shell. They will cut the shell like this. One by one area, they will insert the plate. So all plate will be inserted and the new bottom will be welded here, here, and all bottom. Well, plate can be brought back from top side also. It is allowed by the code. Okay.
If it is annular plate, they will insert
Yes, annular plate first insert it and weld it one by one portion because tank cannot fall. We have to put the anchor, everything, and we have to weld it. That is, so we have to keep this and do it. This is called a new bottom insulation. Okay. Now, when you are installing new bottom, there may be problems coming. For example, we have a nozzle, existing nozzle with the reinforcementing plate, which is very close to the shell to bottom. It will not meet the 650 minimum 3-inch requirement. Then what we have to, we have again options. One option is we can, if possible, we can trim the plate. Reinforcement one option. Second option is we can cut it and make a tombstone soap. Weld with the shell to bottom. If both option is there, remove it and replace, shift it to upper side. That is one. Yeah, not that area one. The whole shell we have to cut. Shell. Yes, not full shell. Only this area. This area, see, for example, if it is a nozzle is here, nozzle and reinforcement, which is very close, we will cut the plate like this and put a plain plate here and replace the nozzle in the higher elevation. That is the one. Another problem when you are installing new bottom will come floating roof legs. Floating roof will have a floating legs. When the floating roof coming down, they will sit on the bottom. Now, how much height you increase here, that much height you have to cut the floating roof legs. Or if the owner operator don't want to cut the legs, it is allowed by the code. Only thing is the floating roof level will come down. Okay. So these are the key points. So highlight this one. When installing a new bottom above, it may be necessary to alter the existing shell penetration in the bottom course. If the new bottom is slated through the tank several inches above the bottom, the spacing between existing well shall meet the 650 requirements. Then highlight the 910.12, 910.2.1. The existing reinforced plate may be trimmed to increase the spacing. You can trim it. The 910.22 is the open book question. The existing rim may be removed and a new reinforcement added except the reinforcing plate not permitted in the stress relieved assembly. We can cut and put a small reinforcement plate, but when it is PWSD already, it is not allowed to cut and replace. Then last line, the new replacement shall be in accordance with 9.7, maintain a weld spacing. A tombstone shaped reinforcement may be reused. So when you are welding shell to bottom, you have to use a tombstone.
Especially nozzle. If we want to replace from that location.
We can replace it. Only reinforcement plate, we cannot cut and put a new plate. Because it is already postal gated. PWSD. Yeah. Yes. Yes. Then this is the way we have to cut it. You can see here, we can trim it or cut a new plate. The existing penetration may be moved by cutting the section, fitting under reinforcing plate. Then highlight the 9.10.4. A new bottom may be installed through an existing tomb post reinforced to provide all the welding. Then we can, already there is a tombstone plate, we can cut it and remove. Remove only that portion of the existing necessary to weld. The lower edge of the ring shall be cut reasonably straight. When you are cutting through the reinforcement plate, you have to cut it straight. See, what is the meaning? We have a shell which already have a nozzle and we have a tombstone shape with this one. And you want to install a new bottom. Then what we will do, we will cut it like this. Same tombstone, we can use it. But only thing, it should be straight because when you are cutting, it should be, we have to cut it straight. Then these are not important. These are not important. Then we'll go to the tank bottom repair. Tank bottom repair, again, there will be around 4, 5 questions they will ask in tank bottom repair. Now, this is another important, and tank bottom repair can be divided into two groups, general repair or repair in the critical zone. What is the critical zone? From the shell, 3 inches. Critical zone, we have a separate requirements. Generally, most of the exam question in the bottom repair on the critical zone area. Okay. Now, what we will use for repair? Patch plate. What are the important thing about the patch plate? What should be the patch plate minimum size? Size. நான் சொல்லவே இல்லை இது வரைக்கும். Size வந்து there are two rules. If it is crossing any weld, minimum 12 inch. Bottom lap weld. If it is within a plate, not crossing any weld, minimum 6 inch. Only thing is from any, so where we will put a patch plate where there is a corroded area, so it should overlap at least 2 inch. Suppose see, this is my bottom. I will explain it. I have a bottom plate like this, which is overlap. Okay, bottom plate like this. Now I want to put a patch plate for a corroded area. Then my patch plate size be minimum 6 inches is sufficient. But what should be from the corroded area? It should be minimum 1 inch this side, 1 inch this side, 2 inch overlap. But if you want to cross a lap joint, then it should have minimum 12 inch size. Because any lap, it should be 6 inch. It will do that. These are the two conditions. And anything we are welding, suppose this is your shell, and the bottom weld, you want to make a patch plate in this area, then it will be, so suppose this is a bottom tombstone shape. We have to put a tombstone. You can see the sketch here. See, come to the next page, there is a sketch. Please go to the page number, figure 9-3, 30. Welded on patch plates. On tank bottom, just to understand this drawing. You can see anything you are attaching shell to bottom weld, it should be tombstone shape. What should be the minimum dimension? Should be 6 inch. You can see first one. And if you see anything, you have weld any corroded, see bottom corroded area, minimum 2 inch overlap should be there. You can see that there is a minimum 12 inch. And anything crossing the lap weld, suppose it is crossing the any lap weld, should be minimum 12 inch. Okay, for weld on the place less than 12 inch, this is the within a plate, we can use 6 inch. So anything crossing the lap weld, it should be minimum 12 inch minimum. Okay, now we'll go back one by one. Highlight this one. 9.11.1.1. The use of welded on patch plate for repairing portion of uniformly supported tank bottoms permitted within the limitation and the welded on patch plate. The minimum diameter of welded on patch plate overlap the bottom seam is 12 inch. That is important. If it is overlapping the bottom seam, 12 inch. And maybe circular, oblong, polygonal or rounded corners. The welded on patch plate smaller than 12 inch is permitted. It does not overlap a bottom seam. It is not partially fully existing, and at least 2 inch, extend the corroded at least 2 inch. The patch plate no smaller than 6 inch. It should not be less than 6 inch. Then please go to the C. This is important. Page number 9-14. Welded on patch plate shall not be placed over the areas of the tank bottom that have global dishing, local dishing, settlement and distortion crater. That is closed book question. What is the meaning? Suppose you have a bottom, there is a bend like this. The bottom plate, there is a like this dent or bottom, then you cannot cover with a patch plate and weld it. You have to remove it, cut and remove it. You cannot cover it. Okay. ஆமா இல்ல, அதாவது corroded ஏரியால இருந்து 2 inch, பிளேட்ல இருந்து 6 inch ஓவர்லாப், 6 inch ஓவர்லாப். அதனால தான் see generally this side 6 inch, that side 6 inch. Minimum 12 inch you have to keep. Okay. Then these are not important. Then please go to the page number 91112. Very, very important. Repairs within critical zone. From here only many exam question will be asked. This one page is very important. Definitely there will be 2 to 3 questions in the critical zone. The use of welder on patch plate is permitted for a repairing portion of the tank bottom within the critical zone, provided the 911 requirements were the following. A. The maximum plate thickness for welder on patch plate within the critical zone is 1/4 inch. That is important. 6 inch mm only we can use maximum thickness of the patch plate in critical zone. Second, when a welder on patch plate is within 6 inch of the shell, the welder on patch plate comes the tombstone shaped. That is important. The sides of the tombstone welder on patch plate shall intersect the shell to approximately 90 degrees. Third, C. The perimeter on welder on patch plate within the critical shall be 2 pass minimum and examine as per. So minimum 2 pass weld we have to yield patch plate in critical zone. D. Installation of the welder on patch plate or by any butt welding to adjust an existing patch is not permitted in the critical zone. That also important. E. Welder on patch plate over the existing not allowed in the critical zone. That is, you cannot put the patch plate over another patch plate. You cannot weld it to nearby patch plates by butt welding. These are not allowed in the critical zone. Then G. For tanks with unknown toughness, new fillet welds utilized to install a tombstone shall be critical shall be 3 inch or 5 from the vertical. See, now we told when you are vertical shell, we are making a plate, it should be 3 inch 5T from the angular plate. When you are matching the bottom plate, it will be 3 inch 5T from the vertical weld. We have to shift it. That is important. Open book question. Then I is recently asked, the maximum dimension along the shell of the welder in the critical zone is 24 inch. Maximum patch plate allowed in the critical zone is 24 inch. Then 11-121 also allow important. No welding overlays are permitted within the critical zones, except welding widely scattered pits, pinhole, cracks. So no weld overlays are permitted. And shell to bottom, this one. Now this is again open to question 9-11-123. Welder on patch plates are not permitted in the critical zone on a tank bottom operating above 200 for carbon steel and 100 Fahrenheit for stainless steel. Then 9-11-124 also important. If more extensive repairs are required within the critical zone, the bottom plate to the shell shall be cut out and a new plate shall be installed. More repairs you have to cut out the plate. So this all points. Again, I will repeat 9-11-1.2. Maximum plate thickness is only 1/4 inch allowed. That is important. If it is within 6 inch tombstone, that is important. Minimum 2 pass weld we have to do. That is important. Butt welding with another, this is another patch plate is not allowed in the critical zone. That is important. Over existing patch plate not allowed in the critical. That is important. Unknown toughness from the vertical shell to vertical joint 3 inch or 5T. We have to shift. That is important. Maximum dimension is 24 inch. That is important. Then when the weld overlays are permitted, only weld pinhole and cracks, and the welder on patch plates not permitted in the critical zone, operating above 200 for carbon steel and 100 for stainless steel. When more extensive, we have to cut and replace the plate. Now we will go to the replacement of tank bottom plates. That is, I told a new bottom installation. These are very simple also. So highlight this one. Suitable non-corrosive material cushion such as sand, gravel or concrete shall be used between the old bottom and the new bottom. So we will fill it. The shell shall be slotted with a uniform cut made parallel to the tank bottom. We have to cut the shell uniformly and insert the plates. The cut edge slot shall be ground, removed and slab. Then this is also I told you 9-11-2. For floating roof, new bottom profile must keep the roof level when it's resting on support. The leverness of floating roof can be adjusted by changing the length of the support leg. Support leg we can cut it and adjust. The support leg can remain in the same length to maintain the original height by the same amount, or you can cut it or you can leave it also. That is important. Then 9-11-2.2 last 4 lines. For aluminum floating roofs, the pads may be omitted if the owner operator approve the new austenitic stainless or accept non-metallic. Last line, for aluminum floating roof, austenitic stainless steel or acceptable non-metallic Teflon may install to isolate the leg from carbon steel bottom. Suppose you are using an aluminum floating roof and the legs are made of aluminum, they should not directly contact with the carbon steel bottom. So use a stainless steel or we should any Teflon. That is open to question. Then 9.11.2.3, when removing an existing tank bottom, how you will remove the existing tank bottom? This is given in the next chapter actually. See, if you go to the 10th chapter, I will show you, but these are not important. See, we can cut BB and AA and remove this. How to remove the entire old bottom? We have to remove it. Okay, or you can cut it BBCC also. You can see here, but this is not important actually. BB, we can cut it. So highlight this one only. This is not important. All gauge areas shell to bottom shall be magnetic particle examined and the defect area re-examined and repaired. Then this is a repeat actually. For tanks with the shell plate of unknown toughness, new weld joints in the bottom or on the ring shall be placed at a greater of 3-inch existing vertical joint. That is open to question. Now, suppose you are giving cathetic protection. When you are installing the new bottom, the cathetic protection from the original should be removed. Generally, where they will give the cathetic protection anodes on the bottom of the tank. But if you are installing the new bottom, if you are filling with the sand, you can put the anode between the old and new bottom. And the other you can install. Or if you are filling with the concrete, concrete will not conduct the current. You have to put the anode around the periphery of the tank. Circumference around you have to install it. Okay, highlight this one. For tanks having cathetic protection installed under the existing bottom, consideration shall be given to removal of entire bottom and unissued vessel to prevent shielding of CP current. Removal of old bottom is also important in preventing galvanic corrosion where this is possible. Remove the entire except the unshelled. So we have to remove the entire old bottom. Then these are not important.
அது என்ன சொன்னீங்க அது like old cathode வந்து என்ன சார் பண்ணனும்?
Old cathetic protection வந்து பாட்டத்துக்கு இது அடுத்த சாப்டர்ல கொடுத்திருக்காங்க. ஓல்ட் பாட்டத்தை கம்ப்ளீட்டா ரிமூவ் பண்ணு.
ஓகே.
ஓகே, அடுத்து நான் சொல்றது அடுத்த சாப்டர்ல கொடுத்திருக்காங்க.
ஓகே. அப்போ நீங்க அது மேல கான்கிரீட் சீல் எப்படி சார் ரிமூவ் பண்ணி தான் கான்கிரீட் போடணும்ன்றீங்களா இல்ல அது அப்படியே போடலாம்னு கூட சொல்லிருந்தீங்களா சார் முன்னாடி?
What I said, see, this is your old bottom and you are going to install a new bottom. If you fill with the concrete here, this is concrete.
Yes sir.
Concrete not. So concrete means concrete will not conduct a current.
Yes sir.
So they will install a anode around the tank.
Yes sir.
If you are filling with the soil, you can install a anode here only between the old bottom and the new bottom.
Yes sir.
That's why I told you. But what this is not in this, this is the next chapter. What here says, if you are going for cathetic protection, you have to remove the entire old bottom. You have to cut and remove it and put the anode here. Old bottom remove பண்ணனும், விட்டுற கூடாது அப்படி. ஏனா ரிவர்ஸ்ல கரண்ட் ஃப்ளோ ஆகும்.
Okay. Okay.
Then 9.11.3. Additional welded on plates. If other plate wells such as wear, isolation, structure are to be added to the tank bottom, they shall be installed and examined. If the lab spacing requirements are not met, MP or PT is required for the exposed well. Just to highlight it, not very important. Now, roof. Roof la வந்து nothing important. The minimum thickness of the new roof plate shall be 3/16 inch. That's all. Roof plate, when you are reporting a roof supporting one roof, new plate minimum 5 mm. Yeah. Same self-supporting also nominal thickness shall be 3/16 inch and any plus any specified corrosion allowance. That also important. Then floating roof. Yeah. Repairs leaks in pontoons. All leaks in pontoons or compartment of double deck shall be repaired by rewelding the leaking joints and the use of patch plates. You can reweld it or use any patch plate also. And if you see, if you are rim mounted seal you want to repair it, you cannot, if you want to take it to service, only 1/4 you have to repair one time if it is in operation. Okay, this is important. Rim-mounted primary shoe seals and torsional system can be removed, repaired, or replaced to minimize the evaporation loss and reduce the potential hazard. No more than 1/4 of the roof should be out of in-service tank at one time. Temporary spacer to keep the roof centered shall be used during the repairs. That is closed question. Then mechanical damage. Damaged parts shall be repaired or replaced. Prior to taking, the cause of damage shall be identified. Last line is important. Buckled parts shall be repaired, not tightened. Torn seal fabric shall be replaced. Then next page, these are very simple. If roof rim thickness is less than 0.1 inch, it shall be replaced. The new roof rim shall be 3/16 inch. What is roof rim? The outer rim plate. Okay. Hard taps. Now, hard tap generally there will be two questions. We'll complete it. We will take only 10 minutes hard tap. What is meant by hard tap? Hard tap means installing a nozzle on a shell when it is in service. How we will install a nozzle on a in-service tank? See, suppose I have a tank here. Which is filled with oil. So this is the, and this is my roof. And I want to install a nozzle here. So how to install a nozzle? First, what we have to do, we have to prefabricate it. Prefabricate means we have to take a plate here and weld a nozzle here. Okay, then nozzle we will prefabricate. So if we take this view, this will be like this. Okay, so this will be a nozzle. Then we will make a weld here, and the weld will be NDT tested. After that, what we will do, this arrangement will be welded here. We are not making any hole now. After that, we will put a wall above this. This weld is only called hot tapping actually, in service weld, because this weld should be very careful. If it make any holes during the welding on the tank will catch fire. Okay, I will show you the video of the piping hot tapping. It is very similar to tank hot tapping. A small difference only there. Okay. See, try to understand this. So this is the this is the fabricated tee. Since it is piping, we are keeping like this. Tank, it will be a straight because it is a plate straight. It is a fabricated tee. Then piping will cover both sides. Tank, this welding is called actually hot tapping. Now there is no hole. Inside there is a liquid. This hole we have to take it. Forget about this. So after that, we will install the wall over this. You can see the pipe now. It is not, there is no hole. We will install the wall. Then after the wall installation, this is called hot tap machine. Next one it is called, this is not this one, this will come. So this is a hot tap machine, which is going to make a hole on the plate. So it will install above the wall and it will, so there is a liquid flowing here. it will cut using a cutting tool. Once it cut, the liquid will come, we will close the wall. That's all. We will close the wall and remove it. After that, from the wall, we can take a nozzle connection. That is called hot tap. Okay, so hot tapping should be done very carefully, because otherwise there is a chances of fire and sometimes it may be explosion also. Okay, the welding is only very critical. Huh? Yeah, that's why, because we are welding on the plate only. We are not welding on the hole. We are welding after cutting the hole. It will not catch fire. It will not catch fire, because only there will be two problems in the hot tapping. You will see in 577 actually there is a paragraph regarding hot tapping. So hot tapping, what is the problem when welding? There may be cracks. The reason is because inside there is a liquid, it will cool. So that's only for that only they will preheat and weld it. Second one is, if the thickness is less, then there is a possibility of hole and catching fire. That's why hot tap actual welding may take half day, but we have to qualify the procedure first. We have to ensure how much depth the welder is welding. So the procedure qualification will take more than 2 weeks. So hot tap, we have to convince that it will not cause any safety issues. Hot tap is a serious issue. The thickness everything you have to establish first. Generally, they will use a very small diameter electrode, 2.3 mm electrode only they will use for hot tap welding. Okay. Now coming to the tanks. First, what are the key points you should know about the hot tap? Definitely there will be 2 questions. What are the important thing is, first one, when you are making hot tap, you should keep a liquid level at least 3 feet above the hot tap location. Point number 1. What is the location? At least what is the minimum liquid you have to maintain? 3 feet above the hot tap. Second one, what is the maximum liquid you have to maintain is, in the hot tap location, maximum stress allowed is 7000 psi, 7 ks. That much liquid level, you have to calculate how much load will give 7000 psi. That will be calculated by the engineer. That much liquid level only we can keep. Minimum 3 feet. Maximum, the stress at the location should be not more than 7000. Second. Then hot tapping is not allowed on the vapor space. Above liquid level, hot tap is not allowed. Hot tap is not allowed on the roof also. Third point. Fourth point is, prior to hot tapping, you have to mark the area and you have to check the area whether any lamination is there. At least 4 points you have to measure the thickness in the hot tap location. Any shell which requires PWC, hot tapping is not allowed. Because we cannot do PWC after hot tapping. In service we cannot do. So PWC and the stress corrosion cracking problem shell also we cannot do PWC. So we cannot do hot tap. Now, what is the maximum size of nozzle is allowed? If the impact toughness is known, that is recognized toughness, maximum 18 inches allowed. It depends on the shell thickness. There is a table is given. If it is known, we don't know what is the toughness, maximum hot tap size, nozzle size is allowed only 4 inches. These are the key points. Most of them are open book only. Definitely there will be 2 questions. Highlight this one. Hot tap. For tank shell plates of recognized toughness, the connection size and nozzle thickness, we have to follow 9.1. So this is the next page, 9.1. This is the table. I told you the maximum allowed is 18 inches. Even the thickness is half an inch. If the thickness is 3 by 16, 6 inch allowed. 1 by 4 inch, 8 inch allowed. This table is a open book question. If it is known toughness, you have to follow this table. Then previous, come back. Now, for tank shell plate unknown toughness, the following limitation shall apply. Nozzle shall be limited to maximum NPS 4, close book question. Unknown toughness, maximum NPS 4, close book question. Then the shell plate temperature shall be at or above the minimum shell design for the entire hot tap. Then this is 4 is important, close book question. The maximum height of the tank liquid above the hot tap during the hot tap shall be not less than 7,000. Sorry. Hydrostasis is less than 7,000. That is close book question. The minimum height of the tank liquid above the hot tap shall be 3 foot above during hot tap. That is important. Welding shall be done with low hydrogen electrode. That is important. Hot taps are not permitted on the roof or with the gas or vapor service. That is important. Hot taps shall not be installed on laminated or severely pitted surface. That is important. Hot taps are not permitted where heat of the welding may cause environmental cracking. That is important. Then how to procedure? Highlight this one, next page. Hot tap procedure specific to carrying out shall be developed and documented. The procedure shall be practiced API 2201. Then minimum spacing. Suppose you have a hot tap nozzle. Near there is another nozzle here. What should be the minimum distance? There is a formula square root of 4 RT. The minimum spacing, the hot tap adjacent alpiece is square root of RT. R is a tank shell radius and T is the shell plate thickness. We will do calculation in the afternoon. Shell plate thickness measurement should be taken minimum 4 places. That is also closed book question. Then highlight this one. After the valve has been installed on the flange, a pressure of at least 1.5 ton hydrostatic head shall be performed in the nozzle prior to. So we have to do hydro test based on this formula. 1.5 H2 GY. So what is Y H2? It is given here. First with the height of the tank shell in force that we have to take in inches. G is the specific gravity and Y is the density of the water. Finally, a qualified operator shall operate the hot tap machine and cut the hole in the tank. Now come to the previous page. So this is how the hot tap will be done. And what should be the pipe we have to use? Excess pipe, extra strong pipe we have to use. That is a closed book question. Pipe nozzle should be extra strong. Flange should be class 150. Flange should be class 150. This is the hot tap location. We have to use a class 150 flange. Pipe we have to use the extra strong pipe. That's all chapter 9. Other chapters will be very simple actually. One more chapter 12, reconstruction, will have a little bit okay. So I will stop here. Afternoon we will review questions, chapters. So up to 5 we have completed. Up to 4 we have completed, right? 5, 6, 7, 8, 9. We will review the question afternoon. We will complete the question review also. Because if you go 10, it will be heavy. So recording stop.